technologies and solutions in the ethanol industry, starting with liquefaction and fermentation, when all the key parameters have been carefully studied, which is coming after the distillation, where the integration of the energy coupling is helping us lowering the steam consumption and being one of the lowest in the market. The rectification process allows us to provide one of the best quality alcohol we're having in the market, especially with the hydro selection technology, where Interest is one of the only mastering. The dehydration, where we spoke of, and the evaporation and drying technology with forced circulation, allowing us to having and decreasing the scaling of the unit, allowing our client to use it for our references. Bioethanol with 230 KLPD as an example, and in Argentina with 200 KLPD of ethanol. So thank you very much for your attention, and if you wish to contact us, you'll have the details here.
So, any question? So, Pierre, I want you to just highlight some of the work you are doing with the VSI and on the 2G ethanol.
Sure. So with VSI, we have a partnership and some studies going on, highlighting and working on the molasses storage, where we all know that the molasses could be stored for a longer time, and with VSI we're aiming to find some solution for our clients to store this product during the off season, allowing the clients and the industry to work for a longer time during the year. So we hope all these results will be successful with VSI, and hoping to provide our clients very soon a new solution to store this molasses.
presence being a Indian manufacturer, well, when we are going overseas market, there are multiple standards you have to follow. Multiple norms are there. Yes, those norms are complied by CRI, and more than 40 in 2,600 crore turnover, more than 40 percentage we are catering from the export market. So our presence is there more than 120 countries. And these are the Indian footprints. We have 31 sales branches across India, and our backbone would be, I would say, proudly service. Every 200-kilometer radius, service in the sense I'm talking about the industrial pumping division. So we have service centers, company authorized service center every 200-kilometer radius, and we are having the track record. The downtime, it won't go beyond 24 hours in industrial segment. We have track record, and these are authorized service center where it is there, as I said, every 200-kilometer we are having across India. And addition our strength would be our own R&D. We have R&D facility at Coimbatore, having 120 plus our own engineers, and we are authorized by, we are recognized by Government of India in hydraulic pump industry. We are one among the manufacturer in the world which is recognized by government
awards.
plant. Most of the hydrogen fuel manufacturers are from US based companies are there. We are accommodating their technology, we are accommodating their norms, and we are our major one of the particular product, it is going into the green fuel where hydrogen plants are being manufactured. And this is what I spoke about the product which we acquired from UK based company Tough. Uh, this is excellent product we are having, and proven product for the distillery industry. Start from fermentation, distillation, evaporation, and for the MSDI section and cooling tower, cogeneration for boiler, we have complete range. If we talk about particularly this product, this is known as a N section chemical centrifugal pump. These are centrifugal pumps are there, and which complies ANSI standard. We are not into we are having ISO standard also, but ISO, well, it's a conventional way of method which was being used for the water application with cast iron construction, which for our convenient it has been converted to stainless, based on the MOC, based on the liquid stainless steel SS304 316 316. Yeah.
1 minute.
Yeah. Yes.
1 minute.
Yeah.
Just
Sorry?
conclude.
Okay, only 1 minute is there. Oh, fine. Yeah, I'll give some features of this, where we can go up to 46 bar pressure of delivery. And this is sewage pump. And again, this is mixer where in compressed biogas plant in digester it is being used. We have the technology in Indian pump industry. We are only having this technology who's manufacturing in India. We have CFD analysis also for this product. This is aerator for biological tank aeration purpose. And firefighting. And split case, we have up to 15,000 meter cube per hour. And vertical turbine pump, we have up to 35,000 meter cube per hour. These are few installation. And certifications. And awards. Any questions, sir?
No questions.
Yeah.
So next technology provider is Sovereign Equipment Limited.
Thank you,
Please.
sir.
Thank you
Yeah.
for good presentation.
Yeah, thank you.
Yes, sir. Hello, good morning. Distinguished guests and fellow delegates, thank you for coming over here. I'll just start with the introduction. We started in 98 as a Suviron Equipments Private Limited in Ahmednagar. We are based in Ahmednagar. This is our workshop. We are into specialized equipments like solid liquid separation. We are into rotary juice screen for cold juice in 2 stages. We have a patent for that. For hot raw juice screening also, and we are into mild screening. Then we are into Suviron. We have our own design of Suviron low retention time clarifier. Then filtrate clarification system, syrup clarification system, melt clarification system, then desweetening process, dip bed filters, and we are into also turnkey sulfur-free sugar production. This is our key product. We started this in 98 rotary juice screen, and very modestly, every second sugar factory in India, we have our rotary screen. We have around more than 800 installations worldwide and in India also. We are exporting to many countries like USA, Philippines, Vietnam, Zambia, Rwanda, Iran, Ethiopia, Kenya, Uganda, Guyana. This is a PID. We have an this is a rotary juice screen. Here there is an inlet. We have a caustic soda header for cleaning the screen. We have a wash water header. There is a pump which there is a auto wash water timer is given over there. This is a small photo. You can see the feed box. Wash water header is on the right side. Then the drive assembly. We give a planetary gearbox. It's a chain driven one. Guide roller. It rotates on 4 rollers and 2 on the thrust. This is a front view. You can see the feed distributor which minimizes the velocity, and the thrust roller or the bottom. This is a specially wedge wire screen which we manufacture. It's our own manufacturing setup in Ahmednagar. You can see some wedge bars, and there is a V groove bar. If you see the close up, we weld it over there, so the strength of the screen or the life we get, it is more or better than others. We have also given this is a closed rotary screen we have given for melt. This would be beneficial for the port based refineries. Then we have a mixed juice screening for 2 stages. These days what has happened, because of the fiber or which is a 0.5 mm screen, it cannot handle more fiber because it is a fine fiber. Long thread preparation has gone up. Earlier, if you see the records or with the data which we have collected from 2000, we started in 98. So from 2000 2004, the fiber in that is a dry fiber which we get, that was around 1.35 to 1.5, and 2010 to 17 it has come down, or it is almost 2.20. So because of the fine preparation, we could not arrest the fiber in 0.5. So we have used another screen. It is a gravity flow 0.35. But coarse separation is also required, so the first stage screening is also required. This is a photo which you can see at the top. That is a 0.5 opening screen, and the below is a 0.351. It's a gravity. The flow is by gravity. There is no pumping required. This is a front view. Again the PID, somewhat same. And we have number of data we have collected in number of factories. This is a screen for hot raw juice screening. This is a new equipment we designed around 2015. Here on this platform, I should thank Sonira Sugars, because we jointly did it around 2015. We got a patent for that. Here in first stage screen raw juice, you can see 1800. It comes from 1200 to unscreened raw juice comes around 1200 ppm, 12,000 ppm, then 1800 ppm. Second stage screening in J1 sugars, we have given a second stage screening that comes around 900 ppm. So the fiber has come down, and from 1.20% to 0.05%. That is around 95% removal of fiber. It is a closed one, and here what has happened, because of the temperature, we could separate the fiber from the screen. It is a 0.18 screen, so the area is more. It's by gravity. Here juice sulfide is there, or a defecator. You can see from the up there is an inlet, again there is an outlet. We have given number of walls, so you can bypass the system. There is again wash water header, caustic soda header is there. There are slurry pumps. We can leave it on the mills, or we can take it to the mud tank. This is a photo of it, the installation one. This was the first installation, Sonhira. You can see before screening it was 0.155, after screening 0.018. This is all on dry basis. Here we could also achieve the color reduction of 1500. These are the multiple advantages. From 1500 to 2000 IU we get the color reduction. Then reduction of clear juice turbidity, improvement in transmittance, additional separation of 0.15 to 0.165% cane of dry fiber, lowest fiber in screen hot raw juice, that is around 500 ppm. The white sugar produced was always tested negative in all the installations by the Acumensa method. There are multiple advantages for this. Reduce solid and color loading on subsequent process of juice, syrup and milk clarification. No fiber contamination of sugar crystals. Other mechanical advantages like pump, tubes, pH is eliminated. Increase in capacity of existing clarifier. We found some small capacity increase of clarifier. And moreover, most important, improvement in sugar color, around 10 to 15 IU in normal condition. These are numbers of screen. From on the mills we have 2.5 and 0.35, and again on the process house we have 0.18 screen. So this is a diagram of given over here. We have our own clarifier, so retention time, then suspended particles, sucrose invasion losses, temperature drop is around 2 to 3 degree. Turbidity of clear juice is 5 to 10 IU in sulfitation plant, and 15 to 20 IU for defecation plant. It's a simple in maintenance. Only mud outlet wall is there. It is the only wall required for regular operation. Then we need a polymer for settling. It has wide range of applications. We have given it for secondary juice, primary juice separately, sweet sorghum, beet juice, and foundation. We can use the existing foundation on the, or we can use on we can have a civil structure, a new civil structure, or a staging structure in mild steel. You can see a flash tank. We have a magnetic flow meter, so proportional polymer is added. This is photo installation one. Then on the left side you can see decanters which we had installed, and the right side our clarifier. That is a clear juice.
Yes, please conclude.
Yes, I'll conclude, sir. I'll finish it. Then syrup milk clarification system. This is a PID. Installation photo. Then we have also done raw sugar melting, screening and clarification for sulfur free production. These are the number of advantages. Finally, we express our sincere thanks to Vasantdada Sugar Institute for giving us an opportunity for this presentation. I request distinguished delegates to visit our stall number GS7 in Trade Area 1. Thank you.
Thank you, sir. Next technology provider is Thermax Limited. Please.
हॅलो. नमस्कार. VSI टीमचे मी आभार मानतो हे व्यासपीठ देण्याकरता आणि सर्व सकाळी आलेल्या आपल्या डेलिगेट्सचे जे सकाळी सकाळी इकडे हजर आहेत टेक्निकल प्रेझेंटेशन ऐकण्याकरता. Since many of our delegates are from across the world or from India, I'll keep my presentation in English. So good morning to all. I am Ganesh Daivadkar. I am from Thermax Limited. I head the growth unit for biogas upgradation or the gas purification segment of Thermax. So I'll start. So Thermax as a company in India, I think doesn't need any introduction. So I'll keep my introduction about my company very crisp and I'll be very specific on the technology slide. So conserving resources, preserving the future. So this is the tagline of Thermax and we are implementing it since its inception. Thermax started in 1966 as an energy company and we are going strong as an energy company. In spite of that, we diversified into environment segment as early as 1980. So Thermax, I guess, is the only company in the world which is into energy and environment segment. Now coming to our today's topic. So Thermax, what brings Thermax over here in sugar segment? In sugar, Thermax is definitely present as a renowned boiler supplier, spent wash boiler supplier, bagasse boiler supplier, water treatment solutions, chemical supplier. So all the areas of the industry we are catering. But as the world has progressed towards net zero, towards circular economy, we are now into the bio CNG segment. We are also into green hydrogen, but currently I'll address on the bio CNG segment. So Thermax is catering to a complete bio CNG plant, that is a greenfield bio CNG plant. From as a EPC supplier and also supplying specific purification systems for biogas that is generated from the digesters. So I'll be now today catering discussing on this specific bio CNG purification system. So when we say sugar, it is actually think beyond sugar, think bio CNG and think Thermax, because this is one avenue which will increase the profitability of the sugar segment. So circular economy, that is sugar plant, we have the main product sugar, but the waste that is generated from sugar plant, that is press mud and spent wash. So that can be used as a feedstock or as a substrate for generating bio CNG. Now, why bio CNG is important in today's aspect is because we are currently importing natural gas as a fossil fuel from other countries, whereby our foreign exchange is getting drained off. If we generate this bio CNG or natural gas equivalent to natural gas in India itself, we'll be saving our foreign exchange. So government's aim is today to at least generate 15 million tons of bio CNG in India. Thereby, we'll be reducing our imports. Now coming to the sector of bio-CNG, this is a schematic diagram. So in this, as most of the sugar plants will be having a digester wherein we treat the spent wash. We can here treat press mud also, and from press mud through anaerobic digester on the top left corner, you can see through anaerobic digester, we can generate the biogas as the product, which can be purified into a bio-CNG and compressed. And the digested that remains, that is the lower portion, you can see it can be used as a manure or a fertilizer in the farm. So that is a circular economy that we'll be gaining from this segment. It's a win-win proposition for the industry, for the farmer, for the government. Now, these are the few government schemes that government is encouraging bio-CNG sector. Predominantly what is happening is people from other segments are putting greenfield bio-CNG plants taking feedstock from sugar industry like press mud and generating biogas. So our appeal to sugar industry is that you have spent wash, you have press mud. Why can't we put our bio CNG plants and sell it to the oil marketing companies? So there are various schemes. I'll not touch upon to that. The main scheme I think is Satat scheme, which government introduced in 2018 to promote 5,000 bio CNG plants, and this bio CNG will be used as a vehicle fuel. After rolling out of this scheme, the traction for bio CNG plants has picked up a lot. Players like Reliance, Adani's are into the segment who are putting in the biggest bio CNG plant in the world. So Adani is putting a biggest bio CNG plant in Uttar Pradesh. Fortunately, Thermax is part of that project, and we are supplying the equipment for that project. Also, we are catering Reliance in that. So technologies to convert biogas to bio CNG. So before we go there, we need to understand what is biogas, what are its constituents. So I'll be crisp. I have 5 minutes. I have time, no? So we have biogas which contains CO2 to 30 to 40%, moisture and H2S. So these all technologies cater in removal of these impurities, and only methane remains in the biogas, which is equivalent to a natural gas, and that can be used as a vehicle fuel. So that is a technology, and for doing that we have many technologies, out of which we have listed 4 of them. That is pressure swing adsorption technology, vacuum pressure swing adsorption technology, water scrubbing, and amine scrubbing. In Europe and in Americas, this technology is prevalent, and they are using membrane technology and pressure swing technology for purifying the biogas to bio CNG. But in India, because of the capex constraint or because of ignorance of our people on the methane slippage or the methane loss that happens to the atmosphere during recovery, the technology adoption, the uniformity is not there. So I'll touch upon the technologies quickly. So for purification of the biogas to bio CNG. So this is a pressure swing adsorption technology, predominant in Americas and Europe, because the methane slippage in this technology is hardly 1%. And this is a proven technology in foreign land, and that we have brought here. And same technology we have offered to our reputed players. The purity, of course, so purity with this technology remains 96%. Most of the technology will give purity of 96%. But the methane loss that happens during purifying that or removal of CO2, that is of significance, because methane loss is the product that we lose, and in terms the revenue or the money that we lose. So that we have to limit while maintaining the purity. So this is one technology. So this is the overall, I think, dashboard, but I'll skip this. Second technology is vacuum pressure swing adsorption technology. This is dominant in India. All greenfield projects that are coming in are using this technology. With this technology, also 96% purity is guaranteed, that is methane content of 96%, but recovery of 97%. Unlike the earlier technology which was giving 99%, this is giving 97% recovery, or 3% methane loss, I'll say. So this is the inherent, I'll say, drawback of this this technology, that it will give 3% slippage. Next is high pressure water scrubbing technology, or I'll say water scrubbing technology. So this is a very old technology in India, predominantly used, and many scrubber manufacturers or many distillery manufacturers will be providing this technology. Thermax also does provide this technology. So in this, again, the purity, the methane purity, the top left, 96% can be guaranteed, but consistently giving the recovery or the slip of methane less than 3% is a challenge in this technology. So for this, you need a reputed or engineering company which will design this scrubber system meticulously. So that is the need of the hour. Last is amine technology. Amine is a very proven technology used in refineries basically, and it gives the highest purity and highest recovery amongst all the technologies. But this requires steam, or boiler is required, and sugar industry inherently has a steam. So this can be the technology of future once the norms for the methane slippage become stringent. wherein you require 99% purity, or you limit 1% methane loss from the biogas generation. So uniqueness that Thermax brings, I'll say Thermax has all the technologies we are offering. So we'll not be peddling any one technology and and pushing one technology to a customer. We'll show dispassionately the pros and cons of all the technologies, and it is up to the customer or up to the user to select the right technology depending on his capex and the opex that he has. So. That's all from my side. I'll request my colleague to join me for giving this presentation, continuing this presentation on water. 1 minute. Okay.
So I'll not waste my time since I have got a very limited this thing. So we'll quickly take you through this advanced mechanical vapor recompression technology, primarily for the zero liquid discharge treatment of the wastes. So in this advanced mechanical vapor recompression technology is nothing but wherein the latent heat of the vapors is used to do the evaporation. Unlike we use the steam for the evaporation purpose, so herein the latent heat of the vapors is used for evaporation, and the vapors are sent to a vapor blower, wherein the vapors are compressed, and then there is a delta T of 10 degrees which is achieved, which does the evaporation purpose. So the uniqueness of this technology is this discards the use of steam, which is a costly utility nowadays, and the entire evaporation equilibrium is established by virtue of the latent heat of the vapors. So this results into optimized OPEX, wherein the use of steam is done away. So it's only done by the latent heat which is carried by the vapors. Then we also have the multiple effect evaporator, primarily for the waste treatment, wherein what we do is there is a huge volume reduction which is established by evaporation, and in this ME we use steam, wherein if the customers have got steam as a utility and the power is costly, then some of the customers opt for this particular solution, wherein the waste is concentrated and you typically end up with a gunny bag of powder which can be disposed of in a landfill or a central disposing facility. So that's the multiple effect evaporator for the waste treatment. See, I would like to just touch base on this. The beauty of this technology is the customers end up achieving water positivity. In this whole forum, I think many times we talk about water and water as a waste. We call it wastewater. So my request to the whole audience is let's refrain from calling water as a waste, because water has never been a waste. It was never a waste. It was the most scarce and the most precious resource. So we have to work, this solution helps the customer to achieve water positivity. What is water positivity? Is you achieve, generating the water rather than using it from the natural resources, tapping it down and generating your water requirements on your own. So my colleague Aniket, if you can just in a minute touch base on the CPU. Sir, 1 minute.
you.
Just 1 minute. Just 1 minute. Just fast.
Sorry for that. I'll just take a minute of your time. So what we are coming up with is an advanced granulated anaerobic technology. This is for the condensate polishing unit that we have in the distillery segment. So unlike the wastewater treatment plants that we usually take care of, there are many technologies coming up. So Thermax has a unique technology tie-up with a foreign company, wherein we bring this unique advanced granulated technology to take care of the condensate polishing unit. This technology has its benefit, wherein we reduce the civil footprint of the area, have a higher COD efficiency of that particular system, so that this water can be used again back into the processes, wherein we limit the wastage and the discharge of the water into the ground resources. So basically this is the typical flow of what the system is could be like. Hence in this particular system, wherein we have the condensate polishing unit traditionally been done, wherein we don't have higher COD efficiency or higher COD removal in this particular case, but this technology proves that it can reduce the COD up to 90% in the anaerobic digestion system, thereby reducing the load on the aerobic system and the further treatments that are required to use that water back into the process. So that will be all. Thank you very much.
Thank you for good presentation. Next speaker is SS Engineers Limited, Pune.
Just a
SS
request,
Engineers.
any questions, or if anybody
No
would
question.
like
We'll
to-
take the question
so we can take it later, or you
at
can
this
approach it.
end of the session.
Thank you.
Thank you.
Respected session chairman, all dignitaries and my dear friends. In in these 10 minutes, I shall tell you about about SS engineers, what we have achieved so far, and what technological innovations we have done in sugar industry. Established in 1980s, SS engineers provides turnkey from concept to commissioning solutions in the field of sugar and ethanol. We are specialized in complete sugar plants, distilleries, complete sugar plants, distilleries, cogeneration plants, and industrial boilers. We have rich experience of 40 plus years, and our services include design, procurement, manufacturing, erection, and commissioning. This 40 is not a mere number. Over the year, we have built more than 40 turnkey plants, 275 cane crushing mills, 100 industrial boilers, 8 diffusers, more than 40 cogeneration plants, 4 distilleries, and 4 distilleries. Now I shall take you through some of the main important parameters from 1000 TCD up to 25,000 TCD. We guarantee you minimum power consumption for our plant due to highest crushing for our given size of mills. We assure you 30% steam consumption, 30 to 32% steam consumption by use of falling film evaporators and continuous fans. You get complete expertise, supply and execution from a single source. We provide you optimized design and compact layouts which are suitable for future expansions. So, okay. Now I will show you some of the photographs of the plants which we have installed. This is a Sharayu Agro 6000 TCD plant, 33 megawatt cogeneration. This plant has got a diffuser. Bajaj Hindustan, Asia's largest sugar producers. For them in 2004-2005, we have built up 3 turnkey plants in a single year. Currently, they are crushing above 9000 TCD and they have got 20 megawatt cogeneration. Babanraoji Shinde, this is also diffuser based plant whose capacity is 5000 TCD and 30 megawatt cogeneration. Siddhanath Sugar 5000 TCD plant, 26 megawatt cogeneration. See, this plant in 2008-2009 we put up of capacity 2500 TCD. After that, all subsequent expansions are carried out by us. Currently, this plant is crushing more than 6000 TCD and their capacity is 26 megawatt. Indian Sugar, again a diffuser plant of 4500 TCD. Kukudi Sugar 5000 TCD, 33 megawatt cogeneration. Rohtak Cooperative in Haryana 3500 TCD, 16 megawatt. Rajaram Bapu 2500 TCD, 20 megawatt. Bhairanath Sugar 2500 TCD. Kancheshwar Sugar 3500 TCD. And this is the entire list of our all plants which we have built 2001 onwards. These numbers are more than 40, highest compared with any other manufacturer after 2001. You will see the capacities are from 1000 TCD up to 10,000 TCD and cogeneration is from 3 megawatt up to 35 megawatt. Our record executions in 2004-2005, almost 20 years back, we have given 3 turnkey plants to Bajaj Hindustan of capacity 6000 TCD. Currently, they are running at 9000 TCD. In 2002-2003, we have built up 5 plants and commissioned in the same year. The names are Kukudi, Rajaram Bapu, Bhoramdev SSK, Mohan Rao Shinde and Shambhu Mahadev. The same feat we achieved in year 2014 and 15. We built again 5 plants and commissioned in a single year. Their names are Babanraoji Shinde, Balaji Sugar, Baliraja Sugar, Bhairanath Sugar and Kancheshwar. You can see their capacities are from 2500 TCD up to 5000 TCD. The boilers which you have put up over there are from 80 TPH up to 150 TPH. and cogenerations are from 15 megawatt up to 30 megawatt. So this underlines our inherent design strength, our construction capability, and our execution prowess. Now I shall touch upon the mill, which is an integral part of the sugar industry, wherein cane is crushed and further sugar and other products are prepared. We can design economic and extraordinary mills of any capacity. This is an indigenously designed mill and we have got a patented for it. In 93-94 we got a patent for this mill. The unique composite simple robust design accommodates 3, 4, 5 or 6 rollers on a single monolithic headstock. I shall show you the drawings in just some time. We can provide you milling plants from 18 by 36 size to 55 by 100. We guarantee you more than 20%, 20 to 30% higher crushing for a given size, and I shall show you the results in some time. See, the features of our mills are easy removal of feed roller without touching the pressure feeders. I think you check the other drawings, other designs. There you cannot take out the feed roller without removal of the pressure feeding system. Then we have got very extremely short pressure chute. It reduces the friction and power consumption is less because of that. Because of less pressure chute, we guarantee you the least possible contact angle, which improves the cane feeding, and this is the reason why we always claim that our mill can give you minimum 20% higher crushing for a given size. See, this is a photo of a typical conventional mill. I just want to put one point why we call it as an integral mill, because we have integrated pressure feeding system in the mill. I told you that the same monolithic headstock can accommodate 3, 4, 5 or 6 rollers. For a conventional design, you will see that for pressure feeding arrangement, you will always have to put additional headstocks or fabricated structures to accommodate the additional rollers. But in our case, you will see that on a same headstock, these rollers can be accommodated. See, these are the photographs of the mill. The headstock is same. In first photo, you will see 3 rollers, feed, top and discharge. In second photo, you can see the underfeed is added. So 3 rollers plus 1 underfeed. In third photo, you see 5 rollers, 2 are TRPF and 3 regular rollers. In fourth photo, you can see 6 rollers can be easily accommodated. This helps sugar factories to increase at the time of increasing the capacity. In low cost, you can get very good results with such kind of headstock. This headstock is not a mere geometric arrangement. We have put up a lot of engineering into it. When pressure feeders are very close to the feed and top rollers, you get better extraction and more crushing rates. You will always argue that everybody says their mill designs are best or their products are best, but where are the results? I shall show you some of the results. At Jawar SSK, 20 years back, we have put a milling tandem of 42 by 84, 5 mills. They are regularly crushing 12,000 TCD. At Nirani Sugar, they have got two tandems at one location, comprising of 4 mills of 36 by 78 and 1 mill of 45 by 90. The cumulative tandems provide 22,000 TCD crushing. At Bajaj Hindustan, 20 years back, we have given 40 by 80, 3 tandems. Each tandems comfortably crushes 10,000 TCD. Siddhanath Sugar in Maharashtra, on 4 mills of 30 by 60 with TRPF and 1 mill of 40 by 80, 6,400 TCD crushing is achieved comfortably. At Dwarkadish in Nashik, very small mills of 28 by 56 are crushing more than 4,500 TCD. You can compare these results with any other mills and you on your own will get to know which designs are best. Till date, we have supplied 275 mills and 42 tandems. You can see the 45 by 90 onwards, more than 25 mills supplied. 42 by 84, almost 30 mills. 40 by 80 and 36 by 78, more than 50 mills we have supplied. And 2001 onwards, we have supplied maximum number of mills in sugar industry. This is a list of mill tandems which we have supplied over the period. Overall 45 mill tandems we have given. Now I touch upon very important subject, diffusers. Diffusers are again used to extract the sugar from the sugar cane. The main principle of the diffuser is, it is a mass transfer process basically. The movement of sucrose and non-sucrose from sugarcane cells of higher concentration to lower concentration of imbibition water through a semi-permeable membrane is called diffusion. To make you understand, I will give you the analogy between heat transfer and diffusion. For heat transfer, we need a temperature gradient. The more temperature difference is there, the higher and faster heat transfer will take place. We have all studied this in our engineering colleges. For diffusion, it needs a concentration difference. The sugar concentration difference is more, the higher and faster diffusion will take place. Again, area. For heat transfer, we need more area, more heat transfer. Same way, for diffusion, more contact area of sugarcane cells, or for that matter, any of the material which is to be extracted, is required for faster diffusion. Heat transfer depends on many other.
Sir, interest of time.
2 minutes.
Oh, yeah.
On diffuser, there the other parameters which are used in heat transfer are metal conductivity, heat transfer coefficient, flow velocities, temperatures, pH, velocities. For the same way diffusion, we need temperature control, pH, retention, preparatory index, and water quantity. We guarantee our diffusers give you low power consumption, very low operation and maintenance cost, high extractions, no major foundations. The very important thing is that all parts of this diffuser are indigenously designed and manufactured, which are high capacity chain, drive mechanism, filtration screens and frames with high percolation area, horizontal cane macerators for keeping the cane bed porous, and automation system. Again, one of the main features of this diffuser are, we provide one fiberizer, one diffuser and one mill. Nowhere in the world you will find that diffuser is running on a single dewatering mill. This underlines the inherent strength, capacity and efficiency of our mills. These are the diffuser plants. 6-7 diffuser plants are already running. 8th is under construction of 12,000 TCD. This is the highest number of diffusers we have put up in India compared with any other manufacturer. Boilers, I shall quickly take you through boilers. We provide all sort of boilers running on bagasse, coal, lignites, paint wash and other biofuels. From 10 TPH up to 220 TPH capacity boilers we have installed with pressure of 110 kg and temperatures up to 540 degrees Celsius. These are very high efficiency boilers. They have got ability to adjust to rapid load swings, liberal designs. Again, main important point. For these boilers, we have designed a simply slat type traveling grate. For all other manufacturers, you will see that the grates are either imported design or collaboration with other companies. But this is a first kind of grate wherein it runs on mechanical drive. It does not have very complicated parts like hydraulic drives and T-bars and other things. And such, our 60 boilers are running on this grade. These are the boiler installations. More than 100 boilers we have done. Above 150, 8 to 10 boilers we have given. Above 126 boilers. Above 80 TPH, more than 32 boilers we have given. And this is a list of all major boilers. Process of equipments, we make all kind of process of equipments. Centrifugal machines. In last 10 years, we have supplied more than 250 centrifugal machines. Our more than 12 plants are running on the centrifugal batteries of our own. Recently, we have started with distilleries. Diffusers are very good for ethanol extraction per ton of cane. 2 distilleries are already in running and another 2 are in construction. Spent wash boilers, 6 spent wash boilers we have already provided in the industry. We have got a manufacturing facility in Pune. We have got 5 workshops. These are some of the photographs of the workshops. Pioneering efforts. Over the years, we have done lot of innovation in the industry. Some of them I shall just note. SSTRPF, short space tooth pressure feeders, we put up at Terna in 86-87, almost 30 years back. That time the crushing capacity increased by 60%. Swing type fiberizer hammer, first we put up at Kopargaon in 86-87. Then superstructured mill, as I told you, we introduced in 93-94. After that, we have put up more than 250 mills. Entire juice extraction by only one fiberizer, one diffuser, and one mill combination, which is perhaps nowhere in the world. This we put up in 95-96. Simple slag type traveling grate, again indigenously designed
Sir,
grate. Yes, sir.
you
It
require
last
to wind up,
yeah.
please.
In 2007, these are some of our certificates. And we got felicitated at the hands of Mr. APJ Abdul Kalam for the best techno-commercial entrepreneur. Felicitation by RBI. Best Cogeneration Performance Award at the hands of Sri Sharad Pawar Sahib. Thank you so much. Thank you for your time.
Thank you.
Thank you, sir.
Next presentation by Siemens.
Thank you, sir. Good morning to all. I'm Lalit Salunke from Siemens Energy Business. We are from steam turbine segment. Today we are here to...
Hello. I request everybody to stick to the time, please.
Yeah.
10 minutes only.
Yes,
Thank
sir.
you.
So I'm here from Siemens Energy. I'm Lalit Salunke from Siemens Energy, the steam turbine business segment, along with my colleague Viraj Pawar and Shital Malade. First of all, we are thanking to VSI to providing us this platform to energize the society. So we are starting from problem statement. Sir, screen here. प्रेझेंटेशन मोड बघून घेतलं सर प्रेझेंटेशन मॉडेल आहे ना म्हणजे आपलं हे व्हिडिओज घेतो नहीं येते रे विराज ओके got it आला
We know it just would not work without these industries.
Responsible for nearly 66% of global carbon dioxide emissions.
You look at steel, you look at chemical, you look at cement. How do we decarbonize these industries?
It's really hard to do, but if we don't, the consequences will be unthinkable. To transform industries which can't directly use renewable energy, we need to solve the energy trilemma.
For me, really large petrochemical plants and plastic producers are the next frontier. Hydrogen is going to be a vital piece of it, but it's going to be a piece of the whole energy chain. It's not that one company can do it all alone. It's really how do we bring the different players together, the different technologies, the different business processes, and do it in a partnership way.
It's the interaction of our people together, pursuing the same purpose.
I think there's tremendous power in human alliances.
We've started, but honestly, it's only a start. Because without more of these alliances, the decarbonization of hard-to-abate industries will not work.
Our Siemens Baroda plant, manufacturing facility, a world-class German standards plant. Manufacturers years 0.5 to 250 to America, East Asia. You can find there is a big rotor machinery, machines which can take up to 7 meter long rotor machine. This is the biggest in India balancing tunnel. These are vertical pressing machines. This is our product portfolio. It's a run acquired machine. So it is the impulse technology machine. It works with the lower parameters. It's our reaction machines. It's basically suitable for the small intake plants and distilleries up to 25 megawatt with the efficiency ranging up to 88 to 90%. Our machine SC300, which is also reaction-based machine, ranging up to 50 megawatt with the efficiency up to 90%. So this is our service portfolio.
Last minute.
This is our service portfolio in India. Then across the India, we have installation of up to 2,000 fleets in India, generating up to 20 gigawatts. We are our service and sales offices across the pan India at Durga, Kolkata, Raipur, Pune, and Chennai.
Sir, you require to conclude. We have next session also, so it will get delayed. Please.
So thanks. Thank you, sir.
Good morning, distinguished guest. My name is Dheeraj Rana. I am here to present my company, Uttam Energy. I will just give you an introduction about what Uttam Energy is doing, what businesses we are doing. As a group, we are in the industry for last more than 4 decades. We owned sugar mills, we own distilleries, we have a unit Uttam Energy where we are doing the business for the sugar plant and machinery, boilers, and also we have a Uttam school for girls as a corporate social responsibility. So business solution, we are providing a turnkey cogen power plant for end-to-end solutions. It could be complete power plant, it could be cogen plant, it could be BTG island, or whatever is the requirement of the customers. Then turnkey sugar plant solutions, we as the group known again for 40 years, but in Uttam Energy we reborn say 2012 again. So we are doing these sugar plant by our own under the name of Uttam Energy. This is the latest sugar plant we have commissioned here in Maharashtra. It's a 3,750 TCD sugar plant. With a 12.5 megawatt power plant with it. So we are like in cane handling and proprietary devices. We are doing like end-to-end solution for sugar plant. So we do all our in-house design and manufacturing. Mill design, milling components, everything we are doing our in-house design. This is the milling unit you can see of the same plant. We are doing 3,750 TCD with 3366 mills. Mills are driven by AC variable frequency drives with mill control, automations. Boiling house also we are doing in-house design engineering and process house design with 35 to 40% steam consumptions. Uttam mills are known in the industry since long. So we have acquired this technology from Australia long back. Now we are designing it by ourselves and we are providing mills up to 55 by 110 inch size. The complete range from 30-60 or even less than that up to 55 110 size. It is 3 roller, 4 roller, 5 roller or 6 roller mills configurations. Some installation in sugar industry. We have recently got an order in Kenya for 1,500 TCD sugar plant. As I said that as Uttam Group, we are 40 years in the industry. Many people know Uttam mills and all. But Uttam Energy has started their business recently with the sugar. Say last 4 or 5 years, we are doing the sugar plant by our own. Boilers, we are known earlier with in the name of Lippy Boilers, which in 2012 converted to Uttam Energy as a complete energy solution providing company. So these are some plants which we are executing at the moment. This is a 27.5 megawatt power plant along with a spent wash fire boiler. This sugar plant equipment we did in Bangladesh. This is for BSFIC. We installed the cogen and sugar plant there. Then turnkey 25 megawatt sugar plant we did in Belgavi, Karnataka. This project we did in Punjab, the complete modernization of the old sugar plant. It was a very old sugar plant which was remodified, modernized and installed completely by Uttam Energy. Another 15 megawatt power plant with the 90 TPH boiler and a high pressure segment. Temperature range is 515 degrees centigrade. So there are so many. You can see like in this range we are executing these boilers. As I said that we known from the Lippy time 40 years well in boiler segment. So we did a lot of projects already in boiler and power plants. So some of them are like you can see here another 15 megawatt and then recently in ethanol plants we are doing quite good since this new change of bioethanol policy has done. So we are doing a lot of projects for these bioethanol plants. You can see small power plants with the boilers. It will be a spent wash fired boiler or a grain based for grain based distillery. It will be a fossil fuel or any other biomass fired boilers. Another 3.5 megawatt. So you can see in this small power plant segment, we are very competitive and very good and getting the repeat business from our existing customers. We also did this.
Sir, 2 more minutes, please.
Yes, very small presentation I have. Sir,
no, sir, but still.
Okay,
please.
So this is like straw handling packaging, which we did for this 2G ethanol plant with the first one installed in IOCL Panipat. The project at 2G plant was done by Praj and we did the straw handling facility. This plant we did in Philippines. Just have a look on that. you can understand what quality of work we did actually. This is a power plant. So the construction is done like if you go there, you will feel like say shopping So infrastructure capabilities, just 2 minutes I will take quickly. We have all latest 3D engineering softwares. I'll not take much of the time. You can see our manufacturing facility in Aurangabad. Just a quick look of that, which is very important to show that where we are manufacturing these boilers and equipments. It is at par with the.
Sir, please, interest of time, sir.
Just
no, there are
half a
other
minute,
other presenters are there, sir. I have to give justice to them.
It's almost finished.
So please, humble request, please, please.
Okay, thank you.
Thank you.
You gave time to others, but this is not fair, sir.
Next, Raj process.
Thank you.
Everybody has taken 10 minutes. Okay. Thank you. Thank you.
Hello. Yeah, good morning, everyone. My name is Binu Panikar. I represent Raj Process Equipment. I'm VP Sales of. I take care of the sales part. So I'm very thankful for VSI for taking such efforts, gathering everyone for last 6 months. They have been continuously working on this event, and very thankful for Konde sir, PDA Patil sir, and all the members on this dais. First of all, I would like to question, but I don't expect an answer from you. Will the God be graceful to us? What we are doing presently with the ethanol industry? Government is saying that increase the ethanol. But really, will the God be graceful to us when you go up or wherever you go after the death? Will God be graceful to us? The way we are polluting the industry, we are polluting the nature. Will God be graceful to us? I don't think so. Government is saying that increase the ethanol production, but do you know that every liter of ethanol you generate 10 liter of precious effluent, that is spent wash? To whom will you everyone will give us a solution? Yeah, you can extract some of the other thing, like you can incinerate in the boiler, or you can do some of the other thing with this spent wash. But I don't think so that there has been any perfect solution to this. Incinerating is not an option. That is what we have come up with. And we have been focusing on this for last 6 years, and we have come up with technology that truly gives you a solution. Till 2019, it was in a R&D stage, but after COVID, that is 2020, this technology has really come up with a ready solution. I will explain you how the concept is and what it is. And really, this technology was a game changer, but it's truly coming up with much more benefits like CBG and all other things. In 10 minutes time, I will explain you. And after this presentation, you really will think that this technology would have been really helpful if we would have gone up with this concept for people who has gone for incineration technology. Now this is the spent wash what I am talking about. For C-molasses, for every liter you get every liter of ethanol you get 10 liter of spent wash. For B it's around 7 to 8. For juice to ethanol, after recycling it comes to around 3 to 5. Now what we are going to do with this spent wash? Now this spent wash has a COD of 1,20,000 with a pH of around 3 and BOD of around 80,000. So it has a high organic load. So what this organic load can help us and what we can achieve with this spent wash. Now this is the typical flow diagram, like how the spent wash we're going to treat with that. From the distiller you get the spent wash, ENA, RS, that is your final product. But what you're going to get is the raw spent wash. We treat it in the biodigester. And after keeping it for 25 days, its COD value comes down by 65% and you get the biogas. That's a precious gas. 3 years back, government used to give around 46 rupees in hand. Now you get about 70 rupees when you convert this biogas into a CNG. So rather burning the biogas into the boiler or rather incinerating the spent wash, we prefer that you go with this bio-CNG concept. Now, if you go with the bio-CNG concept, the question is what you will do with the biomethaneted spent wash. The biomethaneted spent wash is really very highly rich in potash if you convert that into a potash rich granules. Now how you going to convert this into the potash rich granules? I'll shortly brief through this process flow diagrams. Later I will elaborate each section. There's an integrated evaporator. After biomethanation, this spent wash will go to the integrated evaporator, and from the analyzer column you get the vapor. You can concentrate up to 5.5 to 10%. That is the digester outlet is 5.5. You can concentrate up to 10% or 8% based on the analyzer vapor load. And then it will go to the standalone multiple effect evaporator, which you can concentrate up to 40. Then it will go to the spray dryer where you use boiler flue gas to convert and some sort of bagasse to raise the temperature, and you convert that into a powder. Then you mix press mud and bentonite and you get a good granulated potash. Government gives a subsidy of 1500 rupees per ton for PDM granule. Along with that, you get a selling price of 7,000 rupees per metric ton. Combining bio-CNG and potash, you get a total saving of 8 rupees per liter of ethanol compared to incineration. I have the comparison. I will show it to you. So that's why we say that going with bio-CNG and this scheme of Raj ZLD will give you a good revenue. So in case of juice to ethanol, you don't have spent wash and you have steam, then this scheme gives you much more benefit. And second thing, the evaporator part, how best is our evaporator, that I will show it to you later. This is a typical, section wise I will be elaborating it. The spent wash which you get from the distillery, it goes to the digester where you reduce the COD load. It's a CSTR type digester for 25 days retention time. Along with this, parallelly, if you have press mud, if you get 200 ton press mud, 100 ton you can store and 100 ton another press mud digester you can install. Both the biogas you can take and pass it to the H2S CO2 scrubbing system. You get bio-CNG both from press mud as well as from spent wash. From press mud, from 1 kg you get around 90 meter cube of biogas. So it's very, very profitable to go for a combination, 2 separate digester, one for spent wash, one for press mud and a common bio-CNG unit.
Bino,
yes,
2 more minutes.
Yes, sir, fine. And this is the bio-CNG system. We have installed a 20 TPD bio-CNG unit in Jagria, where you get 95% pure methane, where we have used biochemical scrubbing as well as CO2 scrubbing system. And this is the multiple effect evaporator. This evaporator has a typical degasifying unit where we remove ammonia and then we feed it into the evaporator, which you concentrate up to 40%. Now this is the patented spent wash spray dryer. Now after concentration, it goes to the spray dryer. How the spray dryer looks about, it's cylindrical in shape. This is like a cylindrical shape, and this is the process flow diagram. What is the main technology in this? That we are using boiler flue gas. This spent wash spray dryer is installed adjacent to the boiler so that we can utilize the boiler flue gas at 130 degrees Celsius. We boost it to 250 degrees Celsius and you get pure powder at the bottom. And this powder has a very good potash content. That's about 21% of potash you have it in it. Then it has a organic content of 25 to 30%. And what we do, this paint wash powder is very difficult to handle. So what we have done is we have gone one step ahead by granulating it. How we granulate? We add bentonite and press mud in it to convert that into the granules. And these granules, you get a subsidy of around 1500 metric ton. This is the letter from the ministry this is like second office of memorandum which government is boosting so that import of potash will be stopped. And this is the customers who will procure this potash, IFCO, PDM, Patanjali, GSFC, Deepak Fertilizer. There's a good demand for this PDM granules. Now this is a typical case study, sir. Just one more minute, sir. This is a typical case study of 120 KLPD molasses-based distillery. If it's a totally new distillery, it's a plain ground. Now you are in a confusion that whether to go for incineration or whether to go for a drying scheme. When you go for a drying scheme, this is the total boiler capacity required, 25 TPH, and you will get a CBG of 21.5 TPD by using press mud as well as there's a separate digester for press mud. And SME, you get 21.5 TPD CBG from this. And this is the raw spent wash incineration scheme where you install a boiler capacity of 55 TPH, the 60% bagasse, 40% raw spent wash. Now this is the steam of, this is the total consumption. Now when you compare both, this document is totally open to all. Whoever wants can contact me. I'll share you this document. You can see if the comparison, you will get a saving of 10 rupees per liter of ethanol. 4 years back, it was only 3 rupees because government used to give 46 rupees. Now they are giving 70 rupees, so it has gone up. So the total saving comes to around 10 rupees per liter of ethanol. That means for 120 KLPD, you will get 12 lakh saving compared to incineration. Now this is a typical, like a total installation. It's a journey from 2015. Raj process, just 30 seconds. So Raj process started its journey from dryers in 2002. Then it went into distilleries, cogen boilers and all. So our main forte is dryer, which we started in 2002. So we came up with the solution that how this spent wash can be dried. So this is the total list of installation. We have come up to like 50 plus installation of this technology. Recently, we are doing in Venkatesh Krupa Sugar Mill in Shirur and Siddhapur Distillery, Indian Cane Power. There's a lot of installation. I will share you this installation list. Recently, back of VINP Distilleries, GM Sugars. Now we have a good presence in distillery as well. We have recently installed 250 KLPD in Venkatesh Krupa. You all are invited to see the plant, how the technology is out there, and around 40 plus distilleries we have an installation list. And dryers, we have a good installation in paddle dryers, spray dryers, tube bundle dryers. We have dryers for zinc sulfate, sulfur WDG, milk powder plant as well. And this is the recent compressed biogas unit which we have installed in Jakriya Sugar for 20 ton per day. In Manjra Sugars we are installing, and Srigonda also we are installing the same. In both it's a turnkey order with distillery.
Binu, thank you.
Yes, sir. And this is the evaporators. Thank you. Thanks. This is our manufacturing facility as well. Thank you.
Next, Man Energy Solutions. Sir, you are requested to stick to the time. Okay.
I'll try my best, sir. Sure. Thank you so much. So, good morning, everyone. And I'd like to first extend my thanks to VSI for giving us this opportunity and all you exceptional guests for being here and listening to all this barrage of information that all of us technologists have been sharing with you from the morning. So I'm coming from MAN Energy Solutions, and I would like to just introduce, because MAN is a very new company when it comes to steam turbines. So most of you would not have heard our name in steam turbines, but you would have one way or the other dealt with MAN. As of today, we will be covering 266 years. So MAN has been here from 1758. We started off as a humble iron works in Germany. And in 1904, we started manufacturing our first steam turbine. So as of this year, from 120 years, we've been making steam turbines. This is just a tidbit. So diesel engine was developed by Rudolf Diesel when he was an employee at MAN. And the first prototype is still available at our facility in Germany. MAN as of today is a 50,000 crore company, completely owned subsidiary of Volkswagen Group. We have 15,000 employees globally in 150 locations. This is just what I was speaking to you about. So we have production sites in 9 countries in Europe, 3 sites outside Europe, and Bangalore holds one of the distinctions of being a global product center, meaning we manufacture steam turbines in India and export it globally. So these steam turbines were manufactured until 2017 exclusively in Germany. As of 2017, we shifted the production to India with the goal of being more competitive in the market and serving industries in the Southeast and the African market. So as I mentioned, we are there in about 150 locations globally for both sales and service operations. Decarbonization. So I'll speak more about this because this is our strategy for the next coming decade. So our goal is to limit global warming by 2 degrees Celsius and contribute to this with our technologies. So these are the 5 pillars which we have developed. Quickly going through PEM electrolysis, so generating green hydrogen using renewable energy sources. Next is green engines. MAN has developed engines which can run on green methanol, ammonia, because our strength or one of our biggest portfolio is engines which are used in marine industry and for power generation. Then we have retrofits where we are replacing engines in our existing fleet with the new engine families that we have developed. And then we have carbon capture and storage. So this is contributing majorly to industries like steel, cement, where there is huge amount of carbon emissions. And our technology will help you in capturing this carbon and utilizing it. And then we have heat pumps, where these pumps are used, especially in the European countries, where we have district heating, district cooling. And we are developing a solution which uses renewable energy to achieve these processes. I'll skip all this. People know about steam turbines, so I'm not going to speak much about it. So our presence in India, MAN is here from a long time, about 70 years we've been contributing to India. So our manufacturing facility for steam turbines is in Bangalore. We have an engine manufacturing facility in Aurangabad, and we have a compressor facility in Baroda. This is a snapshot of our manufacturing facility. We are capable of manufacturing turbines up to 50 megawatts, up to the, say about 45 machines a year. So this is our product portfolio starting from less than 1 megawatt. We go up to 50 megawatts. We have both impulse and reaction turbines. And we have both for power generation as well as drive turbines. So for pumps, blowers, compressors, our turbines can be utilized. And this is again one of the best things. So you must have seen turbines which have top exhaust or bottom exhaust. That's a radial this thing. We have turbines which can do axial exhaust. So we are currently developing a project which is which will be delivered in about April, May. It's a 12 megawatt turbine which we are delivering to Turkey. So anyone who's interested, we welcome you to our facility to witness this turbine. Steam turbine references, as I mentioned, so we've been doing this for about 120 years. We have 2,400 installations globally. So this is one of the first machines we supplied to the sugar industry. So most of the references you find here are for sugar industry. This for DCM Shriram Group, 11 megawatts. We got a repeat order within the next year for a 9 megawatt back pressure, both turbines running wonderfully from the last 2 or 3 years. This is for Ultratech Cement, MP Myher 20 megawatt turbine. This is for a biomass plant in Argentina. And all of these turbines are manufactured 100% in India. This is one of our oldest customers, Reliance Jamnagar, 32 megawatt, 6 turbines running in their plant from 25 years. This is for Al Khalid Sugar, UAE. People who are familiar with the Middle East market, you will realize that they're one of the largest sugar manufacturers. 7.5 megawatt back pressure turbine. This is for Uganda, Kinyara Sugar, 5 megawatts, running again from about 2022. Sexaria Biswan, 3.5 megawatt, running from 2020. And this is just interesting because a lot of people kept asking to me, what is the lowest pressure your turbine can handle? This turbine is designed for 5.62 bar with about 165 degrees Celsius at the inlet. Completely condensing, generates about 1.15 megawatts of power. And this is again the interesting. I'm done. Don't worry. So this was a geothermal power plant, Kenya, 20 turbines, starting from 3.5 megawatt up to 5.5 megawatt. The worst quality of steam. It has every sort of chemical in it, silica, and also comes with about 10-15% of water in the steam. And our turbines are designed to run with that. Thank you so much, gentlemen. I wish you all a great day. Bye.
Thank you. Thank you, sir.
Thank you, Man Energy.
Aqua Systems.
Hello, good morning.
Hello. You have 5 minutes, sir.
Yes.
Thank you.
Good morning. My name is Pratik Bore. I'm from Aquatic Systems. Firstly, I would like to thank VSI for organizing such a good event. So we Aquatic Systems, we are mainly into water and wastewater treatment for sugar and non-sugar industries. We have been supplying to a number of industries since 1990. This company was founded by Mr. Sunil Bore. He started this company in 1990. We have been doing a lot of projects in water wastewater treatment like ETPs, STPs, WTPs, mineral water plants as well for beverage industries. Recently, we have been doing condensate polishing units. These are RO-based condensate polishing units for distilleries which we have been supplying. So if you see the inlet outlet parameters, this is actually a very good technology which distilleries should actually opt, we suggest, because you can use different type of parameters. So if you see the flow chart, you can use process condensate and cooling tower both at the same time. These are the parameters. If you see, this is a 700 mld plant, 700 m³ per day plant we did. The inlet parameters, you can have a look. After neutralization, the TDS was around 10,000, and at the outlet, if you see the plant TDS and all, it is below 250, and the recovery is around 80 to 85%. These are some of the process condensate plant installation we have done. These are the inlet outlet parameters of the plant. The complete plant runs on complete automation. No human interference is required for this, and it has a lot of interlocking systems due to which the RO membranes are completely safe. So there is no reasons for your RO membranes fouling or getting damaged or continuous replacement of it. Mainly consumption in this is only of your caustic, which will be required for neutralization. Complete system runs on automation. Also, recently we did a no. I'm showing. प्ले होता है प्ले तो देख ही होता है
Was the presentation?
Anything. Yeah, no, meeting over. Recent project we did for Ambalika Sugar. This was a 3 ml DTP shipping plant. The entire sugar city water is being consumed for the entire agriculture land which the factory has. Not a single drop of water has been wasted. All 12 seasons, the entire factory is always green because of the CP water what we have been giving to them. And since then, we have been having repeated orders with a number of sugar factories. This is the ETP and CPU plant that we have been supplied to Ambalika Sugar. It's a 3 MLD ETP and 3 MLD CPU plant. It's a sugar CPU plant.
Sir, please wind up.
Yes.
Okay, thank you.
Thank you.
Next is Snyder.
Hi, good morning, everyone. By the time I got the laptop, so I would wish you all a happy Bhogi and Sanskrati festival. So I am Vikas Verma. I am handling the business development for automation inside Schneider. So give me a minute. By the time that technology got fixed. Okay, so once again, happy good morning and very good morning to all of you. And we really want to thank VSI for giving this opportunity to present in front of you and for this great initiative that they have taken in. I am Vikas Verma. I am handling the business development portfolio inside Schneider. So when we talk about automation, we are having the latest technology of the automation that we will be take you through during this presentation. So as a Schneider, we are a technology company who works into energy as well as into industrial automation, digital software solutions, like provide the efficiency as well as the sustainability solution for our customers worldwide. We are around 34 billion company worldwide and having the more than 135 plus 135,000 plus employees worldwide that we have across 100 plus countries. We always believe into innovation, so that is why we spend more than our 5% to our R&D, and one of the R&D center for software solution we do have into India also. So we are one of the local into the global companies that we say. We are not the energy producer, however we really guide people or the to the industry how really we can save the energy and to get the energy efficiency out of it. So we work into the efficiency, energy efficiency along with the sustainability part of it. So we have the business into energy management as well as into the industrial automation, as we can see over here. So as I told, our mission is really to become a digital partner for sustainability and for efficiency to drive it. So through decarbonization for the electrification as well as to drive the efficiency through digital, we really want to drive the sustainability for out of it. this is what all we know, how the digital technologies are really driving the forces into the market right now, because we all know what all are the challenges are there: commodity price, then the capex and the opex cost, how we really want to drive the ROI. But along with these challenges that we have in industry, we also have the digital opportunities, like we have the IoT, we have the AI and ML. These are the engines which really help us to drive our we are empowering our user. First of all, like we are having the more agile operation, and we can see all the operations through remote control facilities at one place, maybe at your mobile, at your smart devices. So all these inside Schneider, we are driving it through the EcoStruxure plant, wherein we are driving the efficiency. We are securing your capex as well as how the install base you have done, because we are driving the cyber security. That is one of the very essential part of it, considering the today's scenario, because everything is connected to the internet these days, right? So this is what we really call it as a EcoStruxure plant inside Schneider. So this is a total 3 layers that we talk about. So starting from the variable frequency drives, or maybe the IMCC, intelligent MCC, or the instruments that are there in the field are directly connected with my edge control layer, where we have the controllers or the DCS systems, right? And on top of it, to drive the efficiency, like to drive the OE, for the analytics part of it, we have the Aviva software solution which are there. And the best part is we are having the end-to-end cyber security, which is really helping us to keep secure our complete capex, basically. This is how we have driving the automation. So we were the first in 1968, like, who has brought the PLC or the control system to the market. And since then we have bring this journey to in 2023 or 2024 right now, wherein we have the latest technology of the controller, which are totally EcoStruxure based IoT enabled controller that we having. And also do we have the cyber security inbuilt. So these are with the native Ethernet backbone that we are driving it. We work into the industry, like as per the segments that we say, starting from the water. Then we do a lot of work from the desalination to the water distribution into the smart cities. Then we talk about sugar industry into the CPG, sugar distillery, as well as ethanol. We do a lot of work into that. Apart from that, we work into space as well as nuclear. So one of the proud movement for all of the Indian, like we all know about the Chandrayaan 3. The Chandrayaan 3 launch was happened by Schneider Electric Controller itself. So that is one of the key driving force for us. Right? So this is as in control system we have really talked about. This is our DCL solution for the sugar industry, for not only for sugar, complete mill industry. Along with that, we are also providing the solution for ethanol for the distillery. So these are completely open, based on open protocols, right? Which are open for the IT as well as the IT and OT technologies. And the best part is these are the sure. These are totally cyber secure. So till now we were discussing about the hardware. So now I am moving towards the digitization of the software force. Basically, this platform is called Automation Expert. Here we are totally decoupling the hardware from the software. Right? These are totally interoperable, and we can connect any hardware which is available, any IO available in the market with this platform. This platform is totally agnostic. Basically, if you really talk about, here we are bridging the gap between IT and OT. As well as this is also compliant with any IT software that we really need to integrate with. So any IT software, let's say for SAP ERP, if really want to integrate with, so we can do the integration with the help of that. Also, we can also do the any integration with engineering layer. Let's say your P&ID, smart P&ID. So we can directly do the integration with our software itself. Last, we are moving. We are right now into the industry 4.0. Like we have seen the 4 revolution till now, and very soon we would be getting into the industry 5.0. So we have the end-to-end software solution through Aviva. Aviva is our software company, which driving the efficiency as well as the digitization that we are providing. So starting from the simulation to supply chain, we have the end-to-end solution, right? We provide the operations, we provide the predictive maintenance, asset performance, supply chain, as well as that starting from the conceptualization when we really think for the plant. So complete conceptualization also can be simulated at one place itself. The last, I would say, this is the Unified Operations Center. This is one of the biggest platform that we have. So here, this is not only for a one plant or one DCS or one SCADA system, basically. This is the system approach, wherein we can do the integration of multiple plants even at one place. Along with that, we can see the complete starting from the design to the operation part of it. Operation, maintenance, all strategies can be defined over there. Third-party databases can be kept over there. And we have a huge install base, not only in India, also into global side also. So one of the example was the Naya Raipur that has been done by Schneider Electric. That was the first smart city inaugurated by Prime Minister Modi. So from there itself we have started. Yeah. So this is all the technologies which we are really showcasing to our stall also. So we'd request each one of you to please visit our stall into third hall S67. Please do visit us, and we welcome you all, and thank you very much for this opportunity. Thank you very much.
KBK.
Yes.
Yeah, good morning to ladies and gentlemen, and thank you very much for the VSI for having us on this special seminar for sustainability at VSI Pune. We represent ABK Cam Engineering, a part of Renuka Sugars Limited, and a 100% subsidiary of Wilmar International Limited. As a group, we are running 8 sugar plants, 3 sugar refineries, and 3 big distilleries. All are supported and engineered by KVK only. So this short snapshot, why KVK? We are having so many advantages that we can go complete erection commissioning, complete EPC and turnkey projects for sugar, ENA and ethanol. See, we are here to, I'm directly coming to the point for the interesting to all of us that this is blending performance on the all over the country basis as far as India is concerned on a state wise. So you can see here with this data that we are almost reaching 12% blending on country basis, and as per government policies it has to complete 20%. So that means by 2025 we need to achieve this target of 20%, and by 2020 we need to complete the target of 20% blending in petrol and 5% in diesel. To complete this target, we need 14 million tons of grain and 4 million tons of sugar, which is a huge feedstock as far as grains is concerned. So we have to have alternative feedstocks. So this is what KBK is now introducing, this idea of matter to ethanol. That means KBK is capable of doing or manufacturing or producing ethanol from solid, liquid as well as gas. You can see from this slide, from this picture, that we have an engineering capability of producing ethanol from industrial off gas also. So that is the complete idea of having a circular economy as far as ethanol is concerned. We can convert waste to energy. And from here over, my colleague Mr. Manik will take over.
Good morning, all the dignitaries on the dais, now off the dais. This is a typical flow diagram of a next-gen ethanol where we are combining the hemicellulose and cellulose concentration, and finally we are getting fuel ethanol of 99.8%, where there are some steps which are involved over here are pre-treatment, depolymerization, free sugar involvement, and fermentation purification. We are having this procedure in a 20 KLPD plant based on palm kernel cake. We got the order and it will be commissioned in 2 years. This is the gas fermentation what we are currently having tie-up with, where we can get CO2 or carbon monoxide from the exhaust gases, couple it with hydrogen through a compression and fermentation with a patented microbe, where we can produce 99.8% ethanol over there. Some of the achievements of KBK: we are the first company to introduce EPC concept in India distillery segment. Biggest distillery what we have commissioned is 700 KLPD distillery on turnkey basis in Sri Renuka Sugars. Complete in-house engineering and end-to-end solution to client. We have our indigenous manufacturing in field of distillery as DDGS dryer and granularized activated carbon column in sugar industry. We have advanced oxidation process to reduce the biological load of spent wash in molasses based and sugar based distilleries.
Sir, 2 more minutes.
Yeah, sure.
2 more minutes.
Yeah, sure. This is the current achievement or the figures that we have achieved in our existing distillery premises with 12 to 14% ethanol in fermented wash, 93% efficiencies in our grain based distilleries with a residual starch percentage less than 1.3%. Without any steam saving devices, without SCC or MVR, we have achieved 2.2 liters per liter of water consumption and 3.6 liter per liter of water consumption in grain mode, with 95% of condensate recycled in terms of process condensate and spent lees. In terms of steam consumption, we have achieved 2.5 kg per liter on molasses based feedstock, including the dry house, and 3.6 kg per liter for starchy feedstock. We have a plant operating less than 450 kilowatt hour per KL, and 99% of ethanol recovery can be possible at any percentage of ethanol that is present in the fermented wash, ranging from 1% VYV to ranging up to 20% VYV to maximum to match 99.8% VYV ethanol concentration, matching IS norms, Australian Union norms, GB norms, as well as EN norms. We ensure stringent quality analysis procedures with with deliverables like QAP, cost and effect analysis, hazard analysis, and safe operating procedures to our clients. Our infrastructure contains 50,000 square feet area with 500 tons per month of production capacity and a manpower strength of 200 plus. These are a pot still supplied to Briggs and Burton for batch distillation. These are some of our project profile. We will quickly scroll into some of our recent installation is Mekalsuta Sugar, where we have achieved 92% solid concentration in DDGS with protein content in maize of around 32% and protein content in rice in 42%. We have Nakshatra Biofuels and Chandrika Power currently in our portfolio. These are some of our ongoing ethanol projects.
Sir, please conclude.
Yeah, just 1 minute, sir. And these are some of our completed projects throughout India, in Karnataka, Maharashtra, AP, Madhya Pradesh, and UP. These are some of the HPCL Laudia, Sugauli, and in Rajasthan. We have a 150 TPD ethyl acetate plant supplied to GNFC Bharuch. These are some of our sugar projects. We can take over any job to improve the productivity in your existing sugar unit or can supply sugar plants. These are some of our project highlights. 200 KLPD in Thailand, 100 KLPD in Roxel Bioenergy, is San Carlos, 125 KLPD, Kilimanjaro, 100 KLPD. This is our recent installation of 60 KLPD at Mekalsuta, 100 KLPD Baramati Agro, 50 KLPD Metahara Sugar. Here we have 250 KLPD. This plant is fully running on ACC to achieve a water consumption of 1.2 liter per liter. This is a 750 KLPD. Can just take now.
Thank you.
Thank you.
Next is Paharpur.
Thank you.
I think after this you can discuss with them. Sir, please stick to the time.
या शुअर सर. नमस्कार. VSI पुणेंचं मी पहिल्यांदा आभार मानतो की हे व्यासपीठ आम्हाला उपलब्ध करून दिलं. हा असा प्लॅटफॉर्म मिळणं खरंच आमच्यासारख्या वेंडर्सना जरुरीचं आहे, कारण वी आर पायोनियर्स इन कूलिंग टॉवर. No need for the introduction. We are 75-year-old company in this industry and supplying cooling towers to all major industries. What are the presentation has done earlier? Whatever the process equipments requires cooling tower over here, because you have to cool the water. Myself is Vivek Gaukar, working as additional GM in Mumbai office, and I have got my our Mr. Kuldeep Rangari, who sits in Pune. VSI we are doing regularly. Now these are the various cooling towers we are manufacturing. That is Powerpool treated timber cooling tower with splash type of fields, and these have got application in all application in distillery, like fermentation cooling tower, distillation cooling tower, liquefaction cooling tower, evaporation cooling tower, and MSDH. Apart from that, now these are the various installations we have done all over world. That is, this is the export job for Philippines. Then this display is at our stall also. Do visit our stall in GS06 exhibit number 1. Then another references are these are the Emperador Philippines. Then these are the typical fermentation cooling tower, wooden towers. Further, we have got various series towers are there. Series 9, Series 10, Series 15, and Series 18. And depending on the capacity, we are getting the various models. And as I told you, these cooling towers are utmost importance in cooling the water in every industry and in distillery. This is a very good platform, because in one single installation we have got 4 or 5 different application cooling towers. Then these comes in single cell, multi cell, as well as depending on the capacity. 10 years back we were talking about 60 KLPD plant, 75 KLPD plant. Today we are talking about 600 KLPD plant or 700 KLPD plant. So such kind of growth is there in ethanol industry and distillery, and Paharpur is the only unique name in this industry. These kind of erections are done. It is not factory assembled product. Assembly has to be done at site. It is like shipbuilding or the construction of a real estate buildings, wherein every equipment comes in a loose and the construction is done at sites. So it is a quite a challenging job for all of us. And with the cooperation from distillery manufacturers, OEM suppliers, we are doing tremendous projects all over India today. Can you say it in Maharashtra, Karnataka, UP? These are sugar-based states, but now based on the grain-based distilleries, we are getting the number of businesses from Odisha, West Bengal, Haryana, Rajasthan, and all other states. So this is now going to boom in the industry today. And various components of the cooling tower, we are talking about structure, casing, louvers, splash fields, fan assembly, gearbox, drive shaft, motor, grids, etc. So based on those components, we do it assembly of the cooling tower, and whenever you enter in any distillery, first equipment we see at these is the cooling towers, and maybe it requires a lot of engineering which is already done in our cooling tower. That is why we are the only sole suppliers in 90% of the market share is with Paharpur. This kind of structure is built at site, and we have got various manpowers. Access is through some staircase or the ladder. Then there are these are the internal components of the cooling towers, like ACB, handrails, etc. And I won't go into too much of details, and I'm not going to give you the references as such, because what we jokingly say to our customer, if you start printing the references, it will be sort of a dictionary. So we just give you the various photographs of ongoing jobs right now in distillery.
Sir,
and these are the various
1 minute.
Yeah, sure, sir. These are the various components like fan stack, fan guards, etc. Then so I'll go quickly based on the time constraints. So these are the photographs which are shown on the sites. Down here. These are the various instruments we are using. This is the construction of the RCC basin which is required at site. These are the various installations. Then mechanicals components are also shown.
Sir, please continue.
I'll complete. Then ladder. And these are our contact details. I am sitting in Mumbai and my colleague Mr. Kuldeep is also, he is in local representative in Pune and will be in touch with you regularly on this. Thank you very much, sir.
So next, Clean Earth, anybody came? So this is the last presentation in this session. Sir, 5 minutes only, so stick to the time.
Sure. I will. Respected delegates and august audience, Namaskar. I am Virendra Jham from Clean Earth Energy Solution India Private Limited, the first company in plate type heat exchanger field from India. We have the product called plate heat exchangers and air cooled condensers. Jointly, they can easily get you the possibility to meet the environmental clearances target. Some customer mentioned just now that they have utilized the products as air cooled condensers and reduced the water consumption to great aspect. I think the claim is already made and we had been instrumental behind that. These two products, like plate heat exchangers, which are of the gasket type and the welded type, are there you are using since long, but they have a question mark in the sugar industry, as sugar industry feels that these equipment get choked, fouled, and they are not as sturdy as they want to have it. Sure, this is the condition because this is the kind of the equipment which came to us in India or cane power industry with the experience gained into the beet sugar, which was mainly in the European kind of the countries. And this product came as an imported equipment to us and we just adopted it. And there, this adoption needed certain kind of the more features, which we have tried to build. And those features we will like to present first, that now you will not face the problem if you specify these kind of the features as well in your specifications, and then we can carry onwards with a good supply to the cane sugar, and then you can have the similar kind of the efficiency which beet sugar could get, and you will not face the problems of fouling, choking, or such kind of the problems, which we will tell you where we have tried as well and we are successful, but we need surely a tweak in the specifications there. These are the wide gap plate type heat exchangers. At the bottom you see a kind of a slide which shows which were being utilized earlier with a very smaller gaps and the thickness of the plates as 0.5 or 0.6 mm, but we have taken it to 0.8 mm and the gaps are now 12 mm gaps, which you can see on top of the plate as well, where the ribs are also there, which gives a free flow kind of the effect. So you have to specify in the plate heat exchanger wide gap with free flow concept built in on the plate. And this will surely give you a kind of a choking free, falling free exchanger, and we have utilized that and shown into the sugar industry as well, but the specifications need a mention of that. Hybrid concept is a new concept. We have taken away the plate evaporator, the normal gap plate type evaporator. We have taken it away. We have combined the features of the tube as well as the plate into this. That is why we call it as the hybrid. And here you see the tubes of around 18 millimeter, where the plate gaps used to be around 6 or 7 millimeter. Here you have the tubes which would be utilizing your any vapor or two-phase liquid, can be juice, can be spent wash for reboiling applications. And the other side you have is the concept, which is the plate concept. So put together you get a very high efficiency, as high as plate evaporators, but they don't foul because there is a tube on the other side which is facing the plate on the next side. And the marvel thing is that this can be put inside the openable kind of a construction. Shell and tube you cannot open like this, which is in front of you. This can be opened. And top of it, this is completely gasket free. You don't see any gasket there. You have completely welded. And in India, we have this facility where all joints of the plates are done with the laser welding at our plant in Pune Chakan. And this you can see the welding quality, and the gaps are large there. Overall, we can say that the Clean Earth, which brings these three projects, we can do 5 things to you. It is distillery. If this product is linked to a sugar plant as a reboiler for a distillery, you will not need a new boiler. We will tell you how, and proven concept this is there, and think about this, that this possibility exists.
Sir, 1 more minute, please.
Sure, sir. All juice heaters in sugar mill can add up to saving of steam by 3%. Air-cooled condensers can easily help you to reduce water consumption by 35%. And this we have proven at Renuka, Pandurang and Gurudat sugars. Refinery metal concentrator in hybrid construction can get to the payback period of 6 months, while coloration within the range of 10 ECUMSA. Capex 2 is less than a shell and tube falling film evaporator. So all these features put through can give you a lot of savings various places. This is a distillery where the reboiler is shown here on 5 columns in the Renuka's Manoli plant. And I'll show you why you don't need a boiler if this is linked to a sugar plant. This is a shell and tube heat exchanger where the spent lees in a reboiler is getting reboiled at 125 degrees centigrade for sure. If it is a shell and tube, you need a 147 degree, which is 4.34 atta kind of the pressure. However, if you utilize this hybrid concept, you will need the only 4.5 degrees centigrade approach temperature and 130 degrees centigrade steam you can use, which can come from any bleed of the sugar plant. Easily done, can be done, and in this kind of a case, you will not need a new boiler if you are setting up a distillery linked to a sugar plant. This example I just wanted to show you, wherein we are reaching, in the case of the raw sugar heating, 42 to 57 degrees centigrade, we are heating it up, and we are utilizing the hot condensate at 92, which can come down to 47 degrees centigrade. And you see, if this is a shell and tube heat exchanger, the 47 will be around 60 degree temperature. So you are losing approximately around 25 degrees centigrade of the heat recovery if you are going with the shell and tube. So this much kind of the possibilities exist, and same we have shown at the defaceted juice. There
Sir,
we can do it with the
sir, please
92
conclude.
cent. Yeah, sure. And this was becoming possible because of the wider gap and the reverse flow mechanism adopted, and 15 years experience is behind that at Godavari, and you can utilize this concept, and this alone thing, changeover from shell and tube to this, will give you 3% saving. Rest is the air cooled condenser, which we have already mentioned and you have seen previously as well, and therein a lot of saving can be done.
Thank you, sir.
This is the reboiler. I'm just finishing. 2 seconds. And this is the surface condenser. So this also was done to save the water. And these are the air-cooled plate heat exchangers, wide gap plate type heat exchangers utilized in the distillery.
Thank you, sir.
On
for
all the alcohol vapors as well as on the evaporator sections, this has been utilized, and there was no cooling tower utilized for this. Thank you so much.
So, I am thanking all technology provider for supporting. So, for before starting next, we'll come back around 11:50 here.
क्योंकि आप उनकी जगह पे आए, वो डिसाइड होते हैं, वो डिसाइड इंटरेक्शन व्यवस्थित वेळ देत जाऊ फार घाई करू नका.
त्या पुढचं लेक्चर सेशन कव्हर करायचं
झालं, व्हॉट फॉर असेंब्ली 6,000
चलो किया ना? So, good morning, everybody. So, I feel privileged to welcome you for this third technical session on challenges and opportunity in bioethanol. We feel honored to have with us Mr. Atul Mule as a chair for this session. I welcome you, sir. So, please take the dais. Now, I request 5 distinguished speakers for this session to occupy the chair. Mr. Y.B. Ramakrishna, Dr. Paul Boom, Mr. Mainak Chakravarti, Professor S.V. Patil, and Mr. Ajay Nair. So before starting session, I will introduce about the chair. So Mr. Atul Mule is the president and strategic business unit head for bioenergy division in Praj Industries Limited, Pune, and heads global operations. Mr. Atul Mule is a member of various group, Biofuel Working Group, Ministry of Petroleum and Natural Gas, Government of India, founder member and chairman, Bioeconomy Committee of Indian Federation of Green Energy, CII National Task Force on Sugar and Ethanol, Biofuel Advisory Committee, Maharashtra State. So may I request Mr. Atul Mule sir to give the chairman's address. Thank you.
Good morning, everybody. We yet to go to the good noon stage as yet because we have 5 minutes left. Respected dignitaries on dais, respected dignitaries of the dais, let me first congratulate and thank Dr. Konde and the Vasundhara Sugar Institute Management for arranging this such a wonderful expo, which normally happens every 3 years, I believe. And then we have the dignitaries, the speakers coming from international repute, whom we will be very happy to hear to you, all of you. I also want to convey best wishes for this expo from Dr. Pramod Chowdhury, who is the founder chairman of the Praj Industries Limited, who was supposed to be here, but because of some conflicting the appointments, he couldn't join this session, but he has conveyed best wishes to VSI management and all the dignitaries sitting here and all of you here. When we have discussed about the biofuels opportunity in India, I'm sure my colleagues will also talk more about it. And it's a huge opportunity in biofuel, and how and what is that we will go into this presentation. I'm going to touch base on, since some of you are aware about the Praj, but I want to just touch base on the recent happening at the Praj. As so the Praj at a glance, opportunities flagged off in India. That's one of the major thing. Drivers for biofuel, in fact, the dignitary here, like Dr. Y.B. Ramakrishnan, is the one whose tenure this whole biofuel started moving, and we would like to actually listen to you more than probably, but I will touch base on some of them. Opportunities in ethanol at large, challenges in ethanol sector, and opportunities other biofuels. So it's normally the biofuel means people only talk about ethanol, but then other than ethanol, there are huge opportunities in the compressed biogas, biohydrogen, isobutanol, and sustainable aviation fuel. So while doing this, one of the major thing which normally one has to take into mind is that sustainability of any biofuel of this program, the lowest water footprint, lowest overall energy consumption, and lowest carbon footprint is basically need for developing any biofuel, and that's what we at work on that on continuous basis. So when I talk about the Praj at a glance, probably you know that we have almost 1,000 references worldwide, presence in almost like 100 countries. We have almost like 400 international references, 3 manufacturing facilities. Probably the fourth one is getting added in Karnataka now, in maybe about a year, month or so. Over 1,200 employees, 90 plus research science street, and where we have a very good, I think, the collaboration and association with Vasantdada Sugar Institute, where a lot of exchange happening during the tenure of Dr. Sanjay Patil and now Dr. Kunde Patil. We have a lot of association going on with Vasantdada Sugar Institute. 300 patents. About 40% of our business come from the same customers, a repeat business, which takes care of the business cycle. So 10% of the global ethanol production comes from a Praj technology, Praj plant. The significance of 10%, other than the China, of course, where we're not present, but the significance of 10% is like almost like it is 1200 crore liters, and that's what the India's requirement of 20% blending. So equivalent of India's 20% blending product comes from the Praj technology globally. We are celebrating our Ruby year, that is 40th year of operations. We have since we are a listed company, we are paying the dividend for last 24 years. Revenue roughly accounting about 3,500 crores. So that's broad Praj as of today. So opportunities flagged off in India. As I said, that 2018 was a year wherein the revised biofuel policy got announced, and that's really the flag off year, I would say. Though there was a biofuel policy was in place before 2018, but the 2018 has seen a major change. And before 2018, between 2016 to 2018, that Herculean work and the task was done by the eminent people sitting on a desk under the leadership of Dr. YBR, Dr. Sanjay Patil, and Dr. Konde, and then various institutes and various stakeholders, in fact, sitting there also. All of them got together, and this biofuel policy, which is a workable biofuel policy, got into the existing 2018. This policy was also talking about the biofuel of the second generation ethanol. This talked about the sustainable aviation fuel. This talked about the compressed biogas plant. And in today, if you see, this is all reality. In 2018, we talked about it. In 2023, the first, India's first, or probably Asia's first commercial scale second generation ethanol plant, ultra low CI ethanol plant, got inaugurated by Honorable Prime Minister Narendra Modi ji. Some statistics mentioned here, which is talks about that number of farmers benefited, about 100,000 farmers got benefited. Rural job creation was one of the theme, about 1,500 rural job got created. Number of car displayed from a carbon perspective, that is pollution perspective, almost like 63,000 car off the road for almost a year. That was an equivalent of carbon emission got reduced. CO2 emission reduction to the extent of 320,000 metric ton, and that's what the biofuel policy 2018 success. When we talk about what are the such a way that you can also have the same gas production during off season also. And that's the success of this plant. This commercial plant is already in place in Indian Potash Limited. So let's talk about the flag off of, it's not only the 2018 policy, but policy got into reality and the reality started moving. And that's what the success of the policy. So driver for the biofuels, there's a shift in energy mix and particularly in transport sector, because whatever you are talking about is coming from the transport sector. Just to have a quick numbers on the transport sector, as you know, India is going to be world's third largest primary energy consumer, and normally it has always been measured that success or the development of a country that how much energy they consume. And then we are going to be the third largest, or rather we are the third largest energy consumer. And then we have diversified mix, almost like 31% energy mix coming from oil and gas. That's what is then. And then transport sector is the single largest consumer of petroleum product, that's everyone knows. And two major drivers which we thought of in biofuel policy, that high import dependency, 85% of oil and 55% of natural gas we are importing. And that's what we want to curtail, and that's where the policy talks about. That's a major driver. And second major driver was transportation sector, which is second largest GHG emitter in India after the industry, this sector. And two drivers has really seen a major change in the biofuel policy. In fact, the various conferences, the talk, the discussions, even today we are here only for that. And that's for the major success. So need for sustainable, alternate, import substitute product and reducing this GHG emission. So that was the major driver. And we as in India, we are ready to really take this challenge. So reimagine. So during this process, what we have discussed with various scientists, in-house scientists from our technology center, our business development team, our technology team, that why not reimagine the mobility? Why not reimagine the mobility? So today probably you have a fossil fuel. We have a lot of challenges. Energy security is one challenge. High forex outgo, as everyone knows, is another challenge. GHG emission is challenge. Oil price volatility is a challenge, and farmers exclusion. In all of this fossil side, farmer inclusion is not to the great extent. But if you shift to the alternate green opportunity here, when we talk about a biofuel, the first generation biofuel, we talk about a biofuel which is second generation biofuel, a sustainable aviation fuel, mild hybrid vehicles, EV, and flex fuel hybrid vehicles. Probably you would have also listened to Honorable Gadkari Saab. He's talking about this. He's already using Innova from Toyota. It's a full hybrid from ethanol. So 85% ethanol, 15% of gasoline, and there is a battery up to 60%. So that's what the vehicles already started coming into India. And so that's the complete fossil fuel change. The drivers, we can get that challenges to opportunity, and this opportunity is touching based on the farmers. That's what the things are. And then there are various technologies been provided by Prash for achieving these opportunities and challenges. While doing so, energy transition to green solution for the net zero. So what is that? Each of those, like for you have seen this first generation ethanol, there is one, then the second generation ethanol, there is a compressed biogas, sustainable aviation fuel, and biodiesel. Now this graph is very, in a way, complicated, but it's very simple to understand. If you go to the first generation, whether it covers inclusive growth, yes, the first generation covers inclusive growth. Whether it's a feedstock availability is there, so feedstock availability is, as of now, is a challenge. So that's why it is not scoring the high. Whether it coming the CI reduction, yes, it is achieving the CI reduction, but it is not achieving CI reduction to the extent of second generation. Whether technology readiness, yes, there is a complete technology available first generation. And infrastructure readiness also is a challenge. So if you see all those 5 parameters, it scores at a different level. If you take to the second generation, inclusive growth, yes, it also touches the inclusive growth. Feedstock availability, yes, it is definitely feedstock availability. Perhaps it is better feedstock availability than the first generation. CI reduction, yes, it is better CI reduction than that of probably of the first generation. Technology readiness is there already. One plant at IOCL, as I said, started producing ethanol. The another plant of HPCL and BPCL is under construction. Those plants will also come into the production during next 6 months to 1.5 years time. Infrastructure readiness, still a challenge, but inclusive growth, yes. So is the case on CBG, SF, and biodiesel. So the graph talks about all those 5 parameters which are very, very important for any of the success of any of the biofuel. And this graph has been arrived at based on the various discussion and interaction with a lot of research institute and a lot of association, and this is what is been published now. So when we talk conventional biofuels, first generation ethanol, advanced biofuels, second generation ethanol, next gen biofuels is safe, and then we also going to talk about renewable chemicals and materials. So decarbonization of transport industry and carbon recycling is something which is close to the heart of our founder, Dr. Pramod Chaudhary, and that's why we have arrived at two different set of expertise or two different technology routes. So bioeconomy at large will largely, from an India perspective, global perspective, will run from the biomobility side, and other will run from a bioprism side. And for which one has to have an expertise from an ecosystem side or from an investor side, that the feedstock availability, feedstock challenge, the technology, and the product. There are three major pillars and expertise needs to be developed for developing this ecosystem. Biomobility at large, one can see on the right hand side, that talks about the bioethanol first generation, which is a very proven technology. Cellulosic cellulosic ethanol, that is second generation ethanol, which is definitely under technically proven commercial viability establishment is on. Compressed biogas plant is also a developed technology and economically viable. Then there are marine biofuels, then there are sustainable aviation fuel, then biohydrogen, biomethanol, and ethanol blended diesel, which is a very latest trend in happening, ethanol blending diesel. So that's what the biomobility circle talks about, and each one of them are getting a benefit, as I mentioned in that Pentagon diagram of 5 inclusive growth parameters. We'll touch base on that. So from the biomobility, there is a bioprism. So they are also talked about the renewable chemicals and materials. So in fact, some of the topics in today's discussion is also the renewable chemical and material. And this is also ultimately this is going to be a sustainable climatic action through the bioeconomy. Whole of those wheels are going to actually rotate the bioeconomy at large. In one of the conferences, there was some statement given by some of the government officers that during last 5 to 6 years, almost like 80,000 crore rupees equivalent of fuel, import fuel got saved. So probably we have saved over 80,000 crore rupees. Out of that 80,000 crore rupees, 50,000 crore rupees have gone back to the farmers. The whole circular bioeconomy, when you talk about, is started circulating there, and that's why the importance of a biofuel, which is connected to the farmers, is important here. Then what we talk about the transition from fossil fuel to the renewable fuel, that's what is a need. And then yes, today the sugar factory, standalone sugar factory attached with the multiple co-product development, there's a possibility like you have a CNG which is coming from fossil, we have a CBG coming from here, we have a gasoline, we have a bioethanol, biobutanol will come. Naphtha, you have a biochemicals coming from route from this side. Kerosene can be with the biojet, diesel, renewable diesel, and so on and so forth. So there is a huge potential, there is a huge chance of transition from fossil fuel to the biofuel, and that's what the refinery concept is going to happen. And probably some of the investment or some of the industry people already started investing into it, and some of them are in the process of investing, and for which there is a lot of encouragement coming from the government, central government and state government is coming forward for developing such green fuels. So opportunities in ethanol, when we talked about the biofuel at large, so let's focus on the ethanol. So what are the opportunities available in ethanol? There are various numbers started floating into market, but probably we have tried and captured some of the numbers here. That fuel ethanol demand, when I talked about the numbers which are available, are almost like we need about for a 20% blending about 1100 crore liters. The potable demand, which continues to grow with the GDP to grow, the population to grow, which is almost like 300 crore liters. Industrial demand has also been captured at about 138 crore liters. The E100 vehicles, the two-wheelers, which again, Gadkari have talked about, that various automobiles are ready with their two models with 100% ethanol, which is going to take even about 230 crores. The flex fuel roughly will take about 66 crores, additional 7% alcohol about 73 crore, and so on and so forth. So they are mapped here. So all in all, by 2030, the ethanol demand is likely to be in the range of about 3,300 crore. So today, when we talked about 1,000 crore, 1,200 crore, it's going to be almost like triple in next 6 to 7 years time, and that's going to be the demand. And this demand is purely coming from the circular economy and bioeconomy, and that's going to be a crux of the whole biofuel policy. While doing so, feedstock, what is the potential for ethanol and production? So as I said, left-hand side, you see some of the pictures that the sugar, available feedstock from a sugar, one can go up to 700, 750 crore liters. From a starchy, one can go up to again 700, 750 crore liters. and probably lignocellulose, that is lignocellulosic ethanol, that is the second generation raw material available. One can really go to 200 to 200 to 1000 crore liters also. So by and large, whether the feedstock availability is there, the feedstock availability is there, but of course the ecosystem needs to get built for this, and that's going to be one of the major challenges in the coming 6 to 7 years time. Now, challenges and resolution of challenges is something which this expert sitting here will also talk in detail about that, the feedstock availability which we have discussed. And then there are very sincere efforts are happening at this central level, state government level, and the various organization level, that how can we have a uniform policy of having a feedstock availability around the pan India and for the round the year, and that's what the work is already been happening. Probably I would say a sugar industry about 50 years back, what was the scenario on feedstock? Probably the biofuel industry in the same phase today from a feedstock side. I'm sure coming 6 to 7 years time, this feedstock availability challenge is going to go away, and then there is this abundant feedstock availability, because India, we as a country, has a lot of potential to have multiple feedstocks available. Policy consistency, yes, it's very important, and some of the silver lining here that government is committed on that, whether they are giving the prices at the various level from year to year basis from the cane ethanol, but at the same time they are also giving grain ethanol also. Recently, after the maize prices, they have also increased the price. So there is a definite commitment which is coming from the government side. Logistic arrangement, yes, it's still a challenge today, but then addressable challenge. Clearances from institution for the new projects is a challenge, but again, the moment government comes forward, the state government comes, there are various state governments also started having biofuel boards of their own, and the biofuel board also started working very effectively. Karnataka, UP, probably Maharashtra will also coming with the biofuel board now. Non-existence of CI related mechanism. So something is which is yet to work is, yes, today maybe we'll talk more, Dr. Paul will talk about the detail that CI reduction. There is an established mechanism already there in Europe and USA. Probably India need to do that, and that's what probably the Vasudha Sugar Institute can come forward and build this very validations and certification model for the CI numbers. Lack of connect between ethanol industry and other its connected is like poultry fisheries. So one also challenge, again, that's at the initial phases, the DDGS, which is distilled dry grain solubles coming from the grain plant. There are challenges, there are certain demand in certain pockets, and certain pockets not having demand. Then there are demand for the poultry, there are demand for the cattle feed. So there are various things are happening. Probably again the time has come to really incorporate this together and have a very uniform policy. So many agencies, teams, associations are working towards resolving these challenges, and I'm really glad that we, from a Praj perspective, are also one of the stakeholders who are supporting on these challenges to be addressed. So apart from ethanol, what are the approaches in other biofuels and renewable materials? I will just go through of some of the slides on probably want of time. That sugarcane on a grain biomass, you can get a protein, and then protein can either in the form of DDGS or it can be in the form of human protein. You get a carbohydrates, and then you have a range of product like ethanol, isobutanol, isopropanol, lactic acid. Then you have an organic residue for a biogas and an ingredient. Then you have an ash and probably biofertilizer, and the potash recovery from ash is becoming now a buzzword, and there are various technologies are working. Government is also encouraging those. So one can see the green ones are already been established, ready to offer. R&D type work is already going on ethylene and isobutylene, and some of them are like conceptualization like isopropene. So this is again at a large scale. When we talk about the biorefinery, the shift is going to happen like for any sugarcane based complex or any grain based complex. One can really see for decarbonization of transport sector and carbon recycling through bioprism. So that's what in future next 6 to 7 years time people will look. There is a compressed biogas technology, as I said, I touched based on that, and this it is not only from press mud, it is also coming from the various agromass basis, bagasse, rice straw, and any other filter mud. That's also the technology which is well proven, and our first plant of Hindustan Petroleum, that's our first plant in Hindustan Petroleum Corporation Limited, will undergo commissioning phase probably in next 2 months time. That will be, and the first another plant is already in Jamnagar. It is also getting developed again from the rice straw basis. Then green hydrogen is an area which is again one of the I would say the point which every forum wanted to get discussed. The challenges on technology, the challenges on commercialization, and I'm sure that many agencies, including Vasudha Sugar Institute and various research institutes, IIT Delhi, IIT Mumbai, IIT Chennai, everyone is working on that. and probably we would like to listen more again from the eminent speakers from here. That's what the commercially making viable is the challenge, but I'm sure with the way we have gone ahead on the various biofuel, it will be also made available within next 2 to 3 years time, and we at Praj also are working on the same. Volume maximization isobutanol production is one area which is where we have tied up with Geo, and Mr. Paul talked about it in detail about it, from an isobutanol from the sugar streams. Sugarcane biomass to sustainable aviation fuel is one area which again Paul will talk about in detail about it. That, as I said, that the first commercial scale flight already been got from SpiceJet, already been flown. And lastly, one can see the farm to biofuel. So eventually, probably a decade onwards, one can see this is a reality that you have a farm, then you have raw material preparation section. It can be multiple raw material preparation section. Then you have a pre-treatment, hydrolysis, mixed sugars will come in, and then you have an option of distillation reagent either to produce ethanol, sustainable aviation fuel, or polylactic acid. Eventually, it can go for a bioplastic. So the complex is going to be no more going to be a concept. It's going to be a reality in coming 5 to 7 years time. So that's all from me. Thank you very much for your patience listening. Thank you very much.
Thank you, sir, for your informative presentation. Now I would like to take opportunity to introduce our next speaker of this session, Sri Y.B. Ramakrishna. Sri Y.B. Ramakrishna is the member of expert committee from the working group of the Biofuels, Ministry of Petroleum and Natural Gas, Government of India. He is the chairman of the task force of the methanol and DME production from the biomass Niti Aayog, and he is the chairman of the biomass study steering committee, DST, TIFAC, Ministry of Science and Technology. So now I request Mr. Y.B. Ramakrishna to give his presentation.
Very good afternoon to all of you. The dignitaries on the dais, after the dais. Let me take this opportunity to thank VSI for having invited me and share some of my views. As rightly pointed out by Atul Muleji, that though the session is talking about ethanol opportunities, I think the opportunities are much beyond ethanol. Ethanol is only a starting point. And specifically, I would like to focus on the policy issues, what exactly has happened in India in the last 10 years, where are we heading, and the kind of opportunities that are there specifically for the sugar industry to reposition as energy companies. I will only focus on the energy companies, but there are opportunities to go beyond energy company also, looking at biomaterials and biochemicals and things, stuff like that. But let me focus more on the energy part of it. Well, when we talk about the biofuel program at the global level, almost every country has been talking about biofuel and they have a program. And there are two major drivers, the energy security and the environmental concerns are the two primary drivers. India being an agrarian society and our agriculture being at crossroads, we are also looking at how the biofuel program can really become a tool for rural development and, giving an impetus to the local economy. As rightly pointed out by Atul Muleji, I mean, it's not biofuel blending is not a new program. In fact, we started out in the recent past, we started the program in 2002, 2003, when Ram Naik happens to be the petroleum minister. And I still remember, we had organized a conference in Bangalore where we had about 40, 50 members of the sugar industry who came there as a delegation requesting Ram Naik to start the blending program. And that particular conference, he made an announcement saying that we are going to start it. This happened in March 2003, and by June 2003, he had started the blending program. Unfortunately, it so happened that in 2004, there was a new government, and they did not take the whole program forward. But we had a policy in 2009. The policy was a good policy with a good target to do 20% blending by 2017 of ethanol in petrol and 20% biodiesel blending. But unfortunately, there was no program to get there. We had a good policy in place. And that's where the big difference was made in 2014. And when I was requested by Government of India at that point of time to be the advisor to the petroleum minister and help them drive the biofuel program, when we reviewed, to our surprise, we realized that the ethanol blending program was at 1.4% against the 20% target that we had to achieve in next 3 years' time. So we were not going anywhere. And that's when a national working group was constituted, and I was requested to chair it. And, I had the opportunity to work with Atul Muleji and many others, who were there as members, and they helped me really put together a new policy and a new program for the whole country. And as you see, in 2018, we set a target to achieve 10% blending by 2022 and 20% by 2030. And incidentally, with all the steps that we had taken, we were able to achieve the 10% blending 5 months in advance. And with the kind of steps that we had taken, we had the confidence that, we may be able to advance the 20% blending target from 2030 to 2025. And we are on the target to do that. We've already achieved 12% last sugar year. And I think, we are on track with all the kind of policy, inconsistencies that we are talking about. We would still meet those kind of targets. That's the kind of confidence that I have. So the biofuel policy itself, as he rightly said, focuses on first generation, second generation ethanol, biodiesel, compressed biogas, and some of the futuristic fuels like sustainable aviation fuel, methanol, dimethyl ether, green hydrogen, etc. Now, when it came to first generation ethanol in 2014 onwards, several steps were taken. First and the foremost, the pricing of ethanol was at 28 rupees. And obviously, people were not, the producers were not happy with the kind of revenues that they were generating. And OMCs were not picking it up even at that such low price and doing the blending. And, there were a lot of issues like, the taxation, interstate, transportation of the ethanol and things like that. One by one, all those things were taken care of. And with the kind of interventions that were made. And also, I'm talking about that interest subvention scheme, which is a very important thing for people here to understand. People always keep telling me about the food versus energy kind of a security debate. Now, what happens if sugar is being diverted to produce it? Incidentally, in 2014-15, when we realized the sugar prices had dropped and our production was in the range of about 30-34 million metric tons, and our consumption was only 24 million metric tons. And then almost about 8 to 10 million metric tons of sugar had to be exported out of the country, and the international prices were much lower than our production costs. Government was spending something like 5,000 crore rupees as subsidy to encourage the export of excess sugar that we are producing. And we were not allowing the bee molasses or sugarcane juice to be converted into ethanol. So our argument from the working group was saying that, you're spending 5,000 crores, and that sugar is going out of the country without affecting the sugar prices within the country, without, we will be able to divert that excess sugar and produce, ethanol. And that 5,000 crore rupees that you are talking about, why don't we spend that kind of money in creating the kind of infrastructure that is really required for building it? Government agreed, and that's how that inter-subvention scheme on first year ethanol came into. And you have the prices. This is the latest price from 28 rupees in 2014. This is where we have now transition, and you get prices almost up to from sweet corn up to 71 rupees a liter, and the lowest price that you get is something like 56 for the C heavy molasses. So this is where we are when it comes to prices. Now, if you see the steps that we have taken, in 2012-13, it was so low, the production was so low. In 14-15, I think 500-600 crore liters was what was being procured for blending. And now we have already crossed the 5 billion liter kind of, and at 22-23, as I mentioned, we did cross 12%, and 5 billion liter is what the procurement was. And now from year to year, you see how the procurement happened and how the blending percentage was achieved, except 1 or 2 sugar years where the blending came down a bit. You see that there has been a very consistent growth. Now, okay. As he was mentioning about the second generation ethanol, you're also talking about the availability of the feedstock. Being an agrarian society, in 2015, there was a study that was instituted by Ministry of Science and Technology under DST Type Act. Incidentally, I chaired that study steering committee. And from 11 major crops, what has been left back, the agricultural residue that has been left back on the farmer field, was something like 187 million metric tons. We produced about 1 billion. Out of the 1 billion metric tons of agri residues, there was already a lot of usage, but what was wasted on the farmer's land, burnt or unutilized, was in the range of about 187 million metric tons. And India has so many varieties of different crops that we grow. I'm only talking about 11 crops. So if you really take the top 50 crops, then it may be going into about 2.5 to 3 billion metric tons. The challenge that we have is aggregation, storage, and making it in the, making it available in the form and factor it is really required for the processing, whether it is 2G, CBG, or whatever it is. So that is where been the challenge, and that is where a lot of policy interventions are there at this point of time, and encouragement to bring in investment into creating that kind of supply chain. When on this, I want to take one more minute on that particular feedstock. When we are talking about various programs, most of the feedstock comes from our wasted resources like agricultural residue, municipal solid waste, or some waste that are being generated from the industry. But then the most wasted resources in this country is the land owned by the farmers. I'm not even talking about the wasteland categorized by the government. I'm talking about the land underutilized or wasted by the farmers. That runs, you will be surprised, about 45 to 50 million hectares of land. In the last 20 years, we have not grown anything. These are all arable land where farmer could have done it. For various reasons, there have been no agriculture there. And another 70 to 80 million hectares of land, we have been raising only one crop during the monsoon. That means for 7 months in a year, we are leaving that land barren. So we have the land which has been wasted. Can we think in terms of engaging the farming community with the right kind of interventions and with the right kind of energy crops? We can talk about energy crops, food crops for meeting our protein requirement, which is, and growing our oil seeds. But if you are able to make use of the land which is wasted at this point of time, involving the farming community with the right kind of interventions, let me tell you, India can be a bowl of not only the food and fuel. Food and fuel both can be supplied, if not to the whole world, but definitely to the whole of Asia. It is possible for us to do that. But that is the kind of opportunity that we have when it comes to feedstock. And I think, when we started the white revolution in this country, we also had the challenges of supply chain. But today, nobody talks about the supply chain issues in the milk industry, and we have become the number one country when it comes to milk production. And this has happened in 40 years. 1981 is when we really, Koreans started the whole thing. And in the bioenergy sector also, it is possible for us to become the major supplier of energy and feedstock that is probably required for the rest of the world also. So when it comes to feedstock, I'm very positive about it. It's not really a negative story in India. It is a positive story with the right interventions. And of course, on the second generation, we were supposed to put 12, 4 are being fast tracked, and 3 of them are coming with Prash technology. And one other plant with bamboo as the feedstock is coming with Chempolis technology from Finland. As he mentioned, Ivosier plant has been commissioned. We are looking forward to a day when you really take it to 100% capacity production, and that is when the investor confidence really in the technology really goes up. But let me tell you, when it comes to second generation ethanol, we have already become the world leader. Across the globe, people have set up this plant and they have withdrawn. Basically, some of the technology challenges that they had, they could not overcome. But in India, we have overcome all the technology challenges that we have. And the challenge that we have is how do we really bring down the capex and the operating expenses. I think that is where people like Praj and a whole lot of organizations have been working on that. And I am telling you that once we build about 5 to 10 plants, the second generation ethanol will be on par with first generation ethanol. It's going to happen in this country. Well, this is the Praj picture that I have. This is the 12 ton per day kind of a demo plant, which is very close to Pune. And this is the other picture of the Panipat plant that Praj has built for IOCL. Another picture of the distillation column, I would. Now, when it comes to sugar mills, I talked about the capex and opex and all that. This is something that can be brought down considerably, basically making use of some of the infrastructure that is already available in the sugar industry. You have fermenters, you have distillation column, you have a lot of utilities that are already available there. Now, it is possible for us to have the second generation technology as a bolt-on technology to the existing plant, and that is going to help bring down the capex considerably. So this is something that the sugar industry has to seriously look into. And another area is on the enzyme. If when you talk about the operating cost, when the cost of ethanol coming from the second generation, almost 30 to 35% of the cost is enzyme cost. And we are today importing that. So we initiated some work, multiple initiatives in 2017-18. Today, we have enzymes which are being developed within India and, at very competitive prices and without compromising on the quality. We are able to deliver the same kind of, performance that, where is it? Okay. Performance that the multinational company has been able to provide. So these are all the factors which is really going to help us bring down the cost as we move forward. And the other thing that is going to make the whole second generation ethanol sustainable is the kind of byproduct valorization that is possible in the entire value chain. Lignin comes in as a byproduct, and lignin can be one is currently in all the 2G plants, lignin is being burnt to generate the heat and steam that is really required for the process. But as we move forward, we had to think in terms of converting that lignin into much higher value added products. And incidentally, Praj has the technology to convert that into lignosulfonate and also biobitumen and things like that. Biobitumen as a binder, can fetch much higher revenues than what you would get when you burn the lignin. So these are all the kind of possibilities that are there in the value chain, and if we are able to focus on that and develop those kind of technologies and make them commercially viable, I'll tell you that's how the second generation is going to be competing with the first generation ethanol in the coming days. He talked about the sustainable aviation fuel, and we took a lot of initiative way back, almost about 1.5, 2 decades ago in this area. There were several institutions which were, which had joined hands. In August 2018, the first flight, you talked about the first commercial flight. We were talking about the first test flight that was flown from Dehradun to, Delhi. Incidentally, I was also on the flight, and this flight, we blended up to 25% of sustainable aviation fuel and one of the engine. it was produced from jetrofoil. So, the technology that Praj and Gevo has is from the ethanol route. Ethanol can be converted into isobutanol and isobutanol to sustainable aviation fuel route. But I was talking about the HEFA route where, any kind of oil can be converted into biodiesel and other aromatics. Now, today the technologies are there. Now we have to think in terms of how are we going to really commercialize it. On this, government has been working on some kind of a policy framework which is in alignment with CORSIA. CORSIA is an international agreement on how to really bring down the carbon footprint in the aviation sector. There are certain targets. Government is working towards it. Government has already announced a blending target of 1% by 2027 and 2% by 2028 on all the international flights. And let me tell you, if we can put our heads together and make use of our resources and the kind of technologies that we have developed, this is not a difficult thing to achieve at all. And I think, we will be able to go much beyond that. And that's the picture of the first flight which we took from this. And I'm competing with you. You had one minister. We have 5 ministers here receiving us. So on the biofuel sector, if you really look at this chart, there are different types of wasted resources. I mentioned about the agricultural residue. You have spent wash, pressed mud coming from the sugar sector, MSW, sewage treatment, the sewage, and then recoverable animal dung. That itself, it's huge. If you really look at it, it is possible for us to, if all this is available to us, we can generate about 60 million metric tons of compressed biogas. Incidentally, I just want to share some statistics with you. The total consumption of all sorts of gases today in the country, whether it is compressed natural gas, LPG, whatever, everything put together coming from all the fossil sources is something like 45 million metric tons. And out of that, almost about 25 million metric tons is being imported into the country. And if you are able to achieve this, 60 million tons, you have 100% taken care of your requirement, and then, you have more to export it out of the country. And in the process, you generate about 370 million metric tons of biomanure. It's a compost, excellent manure, which can replace 100% of chemical fertilizers that we have been consuming at this point of time. And that's the kind of opportunity. And in the Satat program, we said, okay, let us just look at, in the first phase, only about 25% of that opportunity. Instead of 60 million metric tons, let's only look at 15 million metric tons. And that itself will replace 75% of the import that we are doing and almost 35% of the total consumption of gases in the country. And, we had a target, ambitious target, to set up 5,000 commercial plants by 25-26. But, it's not happening because we lost some time because of the COVID in between for 3 years. But let me tell you, I think in the next 1 or 2 years, we are going to have about 750 plants becoming operational. And by 2030, we will have those 5,000 commercial plants in place. So, there are issues with regard to offtake. You talked about the infrastructure part of it. The pipeline infrastructure, government is yet to announce a policy, but they have finalized it, where from the CBG plant to the nearest, CNG pipeline, it is possible for you to have a pipeline and inject it into the pipeline. And for that, 50% subsidy is going to be given by the government for up to about 75 kilometers of pipeline. So that's going to be a big booster for the CBG sector. Then you do not have to worry whether the oil marketing company is really lifting it or not. You produce it on a daily basis. Every minute you are injecting it into the pipeline and your revenue comes. So there is no worry about the marketing part of it. So that is the kind of ecosystem that is evolving. And also on the manure that is going to be generated, we have a lot of challenges because, you cannot compare it with the chemical fertilizers because, your nutrient content is low here. And then, the basic advantage with this is, you have the organic carbon which will go back into the soil. Right now in our agriculture, we are not replenishing the carbon at all. So this is where you have so much of organic carbon which can go back into the soil. and you also have certain nutrients. It is also possible for you to do certain fortification of this manure so that it can 100% replace the chemical fertilizers. So we have a huge opportunity in that area. So when you talk about CBG, it is not just the the biogas. We are also talking about manure, which could be an additional revenue stream. And the third one is carbon dioxide. We have to work on the carbon dioxide valorization and see, how we can monetize on carbon dioxide, because every plant is going to generate 65% methane and 35% CO2. If that can be captured and if that can be monetized, there are three sources of revenue. And the fourth, there is one more, which is the carbon. You mentioned about the carbon also. The market is emerging. Government is coming up with policy. For every ton of carbon saved, there is going to be some kind of an incentive that is going to be offered. There are incentives available in European and North American market, but we are going to be putting up a program here, and Ministry of Petroleum is already working. We are trying to make it very simple. For every ton of gas that you produce, you get earn credit. So simple as that. No complicated calculations and things like that, and there will be an ecosystem to market it within the country. So the policy is emerging, looking at the infrastructure that really needs to be created, how the industry needs to be incentivized, and how do you really create the ecosystem for marketing all this product. Everything is evolving at this point of time. And interestingly, this is the food waste to biogas plant in Pune, in the city. I think probably a few kilometers away from where we are sitting. And they process about 300 tons of food waste and produce about 13 to 14 tons of compressed biogas on a daily basis. And this is one, from paddy straw. This is one of the earlier plant that was set up, 100 TPD plant in Fazilka. And this is the first plant under Satat in Namakkal in Tamil Nadu, where they use press mud and poultry field. They use poultry field basically to increase the productivity. You have, probably 4.5% is the yield, gas yields with press mud. With poultry feed, it goes up to 7-8%. So they use that combination there. And I think this is the most important slide. Currently generates humongous amount of bagasse, and most of the bagasse is being used for generating electricity. Now, the bagasse-based electricity used to fetch about 7 to 8 rupees per unit. But with the deployment of the solar, and I don't think any utility is willing to pay the 7 to 8. Once your power purchase agreement ends, you're not going to get more than 3 or 4 rupees for every unit. Then it won't be viable at all. There's so much of bagasse can be released to produce, ethanol, and that lignin can be used for power and heat generation, and further value addition is also possible, as I mentioned earlier about lignosulfonate, bitumen, and things like that. And of course, bagasse to CBG, you are talking about press mud, add a certain quantities of bagasse, and if the microbial consortium can handle both the bagasse and press mud, your gas production really goes up. So these are all the possibilities. Why I am insisting on this is, he talked about the feedstock related issues. The sugar mills do not have feedstock supply chain related issues, and the feedstock that is required for bioethanol as well as the CBG program, everything is available with you already. So now further valorization of this and adding value to that, there are plenty of opportunities, CBG as I mentioned. And then once you have the sugars, whether it is the sucrose or the C5C6 cellulosic sugars, we have the technology to convert them into cosmetic, chemicals, alternative materials, etc. And we did talk about the ethanol to sustainable aviation fuel through the isobutanol route. But there are other routes also now. Straight, you can get other products like, isoprene. Isoprene is, isoprene rubber has become a very popular product at the global level today. So that is going to reduce the carbon footprint considerably. Starting from molasses to any kind of sugar that you may have, today we have the technology to convert that into sustainable aviation fuel, isoprene, biorubber, whatever we are talking about. So huge opportunities are there. And of course, the carbon dioxide. In sugar mills, there is so much of CO2 that is generated in the fermenters. And when we are talking about the CBG program, almost 35% of gas that you produce is CO2. And from this, we have to think using CO2 to produce ethanol, CO2 to lipids and biodiesel, and multiple other products which are possible. So the horizon is growing. There's a huge opportunity for the sugar mills to look at. There are a lot of technologies which have been commercialized. There are technologies which are at the laboratory level ready to be commercialized and things like that. You mentioned about the hydrogen. The bagasse can be used for generating hydrogen. I'm not even talking about the electrolyzer. I'm talking about gasification route through which you can generate hydrogen at much lower cost than the electrolyzers. So you have the resources. All you need is a gasifier and a proper filtration mechanism to get good quality of hydrogen. So there is a new world that is actually opening up, and this is something that the sugar industry has to seriously look into. With one short note, I just want to end my talk, and this is specifically for VSI to consider. Now, when we come to feedstock, one is the making use of all the available wasted resources. Second thing is to involving the farming community and to grow something. And then the third most important aspect is, the increasing the coming up with those kind of varieties. Looking at the productivity and looking at different application possibilities. This is where I think tremendous amount of work needs to be done. As I give you the example of Brazil, wherever I grow, where they have the energy cane. From the same 1 hectare of land, I think we have achieved close to 90 tons per hectare here. Now, the energy cane reduces your water consumption by almost 50%, 50 to 60%, and increases the production to about 180 to 190 tons. Now, the sugar percentage comes down, biomass goes up, but per hectare sugar production remains the same. It is not going to come down, but you would have generated more biomass, which means that the sugar mills may have to crush more cane to get the same amount of sugar, but then you will be sitting on two times more biomass, the 2 times more bagasse, which can be used for all the applications that I have been talking about. So the kind of research that has happened in